Start. Okay, so welcome, like we've been saying, to the Carlson Software Civil Design Module Training by MSoft. And if you got your materials, Jamezi, I didn't ask on your end, but were you able to get your data sets and this training guide? You got those downloaded, okay? Jamezi? Okay. You're muted still if you're answering, so
I'm sorry I didn't.
you didn't get those
Yeah,
links. All right.
I'll go ahead and do that right now.
Yeah, if you go back to that really long email that had
Yeah.
the original link in it, scroll on down and there's a link for a Dropbox connection.
Yeah.
And there's two things in there. One of them is the training guide, which is just a PDF file by itself. And the other link is a folder that says data sets. And so, or data set. So that has all of the sample files in it. So if you'll go ahead and bring those down locally where you can load them up, then you'll have what we need to go through things, okay?
Okay, sounds good.
Yeah, let me know if there's any problem with it too, so.
Okay, thank you.
Yep. So what we've got in this training guide, let me go through a couple of things here, is if you look at if you have yours open on the screen, you can follow along what I'm talking about, but you can see there's a couple of things up front. It's sort of in two halves. The book is sort of in two halves. Excuse me, I'm starting to lose my voice. There's a bit of upfront stuff in the first part, and then it gets into this section over here on settings, and it's just just talks about where they are and what they are. We'll go through some of those as we need, but then you're going to see some of these are in red. Every time you see one of those lines in red, that's an exercise as to what it's going through. So if you look at, if you click on any one of those things in a table of contents, they're hyperlinked. So they'll go to that particular section of the manual. Now there's not a button that sends you back other than whatever your PDF viewer might have, go back to the previous page or whatever. But so that works there. But as you go through this, and particularly if you're not real familiar with the Carlson software, there's a lot of stuff in this upfront part. Starting right here in this points and the exercises with points, if you use points like survey points and things. But in particularly this modeling process and, about adding break lines, evaluating the surfaces, this 3D surface viewer, quick profiles, those sort of things. And then at the end of all of that, there's this putting it all together type of workflow that takes all of these concepts before and steps you through. You basically have a drawing with nothing in it but points. So how do you create the surface, compute a volume? In fact, if I go to that section, you can see it's on page 37. There's just points. And then, if that's a stockpile, how do you compute the volumes of it? Then we design a little borrow pit, cut that into that stockpile, merge the two surfaces together, including the contouring, and then finally design a little access road into it. Now, this is not using the civil tools. This is just with the bare bones, even the survey module that we're creating a center line. We create a profile, which you can see, over here, this profile editor, that's the existing ground. What it looks like when we design our road with proper vertical curves and such, and come into touch down into the flat part of that borrow pit. You can see the berm is up here. And that was back, you see how this comes through here and comes, it comes in through here, goes across that berm into this flat part. And then we take that just as an edge. We offset the left and right edge down 2% and across, I don't know, whatever distance, looks like 10 feet each side for a 20-foot wide road, crowned in the middle, 2%, and then side slopes of 2-to-1, which I see that says ration, that should say ratio, sorry about that. And then create a surface out of just that geometry, merge that in with this same stockpile and borrow pit, so the whole concept here, just a few pages, it sort of steps you through, what you would normally do in that process. Then after that part, and that's on page 63, we get into these actual civil modules. Now, this upfront part, and we're not going to go through all of this stuff. You'll see, you'll touch some of these tools in what we do, but these are exercises that are normally just part of that fundamentals course. In fact, the fundamentals book actually ends at the end of this section. So that's the end of the fundamentals. It's repeated here though, for your use and reference later. This is where we're going to start. It's here with the civil design exercises, and we're going to talk about roadway design, some grading tools. And then after that, there's really only like 2 formalized design exercises, but there'll be a lot more activity, don't worry. But then after that is this section here called the command reference. And if you look back, let's go back to this. This says command reference, general menus, the file, edit, view, draw, and query settings and points. Those are the menus that are available in every one of the Carlson software modules. The command reference then for the civil module menus is these pick up to the right of the points menu and starts with 3D data, surface, SiteNet, centerline, etc. Okay, and it goes through all of the different commands. Now, it only goes through the Carlson commands. In fact, let's go to this edit menu for a second. See, it says the edit menu, and of course, this is really true of all of them, but the edit menu in particular contains both standard CAD editing tools like move, copy, trim, rotate, etc., as well as these Carlson enhanced variations. Okay. And that's where a whole lot of power comes baked into this software. There's things you can do with some of these Carlson tools that you can't do without standing on your head outside in the rain, using plain old AutoCAD or IntelliCAD tools. So those are really some good tools. Now, at the end of the day, it's important to remember that all we're doing when we use any of these tools, whether they're Carlson tools or whether we use the old P-edit or P-line command from AutoCAD, it doesn't matter. All you're doing is modifying a polyline, or you're creating a polyline. You're doing something to standard CAD geometry. You're not going to have anything in your drawing that is not some kind of a standard entity in CAD. Now, sometimes it's a point, or I'm sorry, sometimes it's a block, or it's a group. It might be a CAD point entity combined with a graphic block that's a symbol combined with an attribute block, which might include point number, elevation, and description, things like that. Or you might be able to double click a line that is center line of your road, and Carlson's going to intercept it at that point and load up the center line editor. But if you select it and look at its properties, it doesn't say that it is a center line. It's not called an alignment like you might see other programs like Civil 3D actually recognizes those as those extended type of entities. Carlson doesn't work like that. But so you can select it and the properties of it will say, hey, this is just a polyline. So it doesn't matter if you edit the polyline using the centerline editor or Carlson's 3D polyline editor, or if you edit it by grips, none of that matters, because at the end of the operation, whichever method you choose, you've modified a polyline, or you've, edited a piece of text, or you've done something else. So whatever tool is most comfortable is perfectly legitimate as a way to do what you're trying to do. Okay. So all of this special stuff like center lines and profiles and surfaces, those are stored externally in external data files, but the interface allows you to, react to them and interact with them through the drawing. And so that being said, now that's just sort of an overarching design philosophy of the software. So the way this section, this command reference is built is that everything you see here, for instance, if you look at this menu, it's on the edit menu. There's undo, redo, all the clipboard operations, erase, select, erase single, erase last, and then erase by layer, by closed polyline, erase outside. Those are the Carlson modified commands. And so what this book does here is it only shows you the Carlson commands, if you will. And if it's a standard CAD command like erase last, you won't see it. See, the first one here under the menu here under is erase by layer. Okay. So that's one thing to note. You won't see every command. If it's not shown in here, it's a standard CAD command. Now the help system does show them all. Okay. And then the other thing to notice about this part of the manual is that some of these are red and bold, they're bold type and they're colored red. And all that means is that it's been my experience that these are particularly useful tools. It might be something you've never done before. You may not be aware of it or how it works, but it's worth taking a look at to see what they do. And you'll see some of them are done. Now, there may be others like, set polyline origin here that you might use this 3 times a day and you find it very helpful, and that's perfectly legitimate. It's just that in my particular experience, I may not have. So these are just little things to maybe flag your attention. Okay. And then it steps you through all the different commands. Then there was, file, edit, inquiry, draw, inquiry settings, and then points. Okay. And for the surveyors in the room, there's a command right here on the points menu called search for published control. So if you use like NGS monumented controls out there that steps you through a little interface to let you pick, order A, order B, vertical, horizontal control monuments, and you can bring in their data sheets, even if they're in like UTM meters, NAD 27 UTM meters, but you're working in a NAD 83 US survey feet. If you choose to bring those into your drawing, it will create them in your coordinate file, and it will do the coordinate transformation for you on the fly. So there are little things that are hidden. that might be worth looking at. One big one that nobody is really ever aware of is on the draw menu. On the arc command, even though that's, we all know how to draw an arc using standard CAD tools, and that's fine. But it also, if you look at that menu, you'll see that it has a number of things like, instead of like TTR, which, says, pick a tangent, type in a radius, it might say something like, PC center to PT kind of nomenclature. So it's geared more to the way we think of it. But also on the bottom of that pull right menu, there's a little curve calculator. And this is really, really handy. It lets you select something in the drawing, or you can click 3 points that define an arc, or you can type in numbers. But if you select an arc or you pick 3 points, it will compute and show you their values here. And let's say you wanted to see what a 50-foot radius curve might be, you could just type in 50 feet, and then you could choose, plot, and you could draw it into the drawing. It's really quite helpful if you're doing a lot of curved geometry. And of course, your choice between highway or railroad curve definitions. So anyway, just little things like that to keep your eye on, pay attention to. And that's the structure of that. Then once you're through the points menu, you start to get into the civil module menus. And so that's going to step you through those commands. One of which, let's see if it's, yeah, this one, edit and assign polyline elevations, which is, say this third one down on that 3D data menu. That's one of the better three-dimensional polyline editors. It's very much like the way it works in Civil 3D, if anybody has any experience with that, but it deals with the elevation parts of the polylines quite nicely as well. So anyway, and you'll see that, and you'll see some different examples, little things like now. And any of these, a lot of this text and a lot of this stuff is taken, say, from the help system, and sometimes that help system is not fleshed out as much as what you'll get in this book, but sometimes it's really, really detailed and pages long, and so it's synopsized to be a bit briefer in this little reference part of your manual. Okay, so that's essentially the book, the guide, and it goes through to the last we're on the annotation menu, label, offset, distances, and that's essentially it. So if we go back, starting here, you can see actually this number is getting closer to 40 now, but right here is, now you've got emails from me already because of sending you the links, but I want you to always remember to keep that handy, because part of what you get when you sign up for one of the classes, you become an IMSoft customer, is you get access to us as technical support. And the difference there is you also have free technical support with Carlson. Okay, so and they wrote the program, so that's a pretty good benefit to have. But one of the differences is, and one of the things that we sort of offer in a not in a better sense, but in a different sense, is that I'm not a programmer. was years ago, but I'm a practicing civil engineer. I have my own consulting practice. I'm a contractor for IMSoft, but as part of being an IMSoft customer, you can ask us questions and, we respond to those, and I'll give you the sense of, this is what you do. I know what you're going through from a workflow standpoint. I'm not a programmer that had to, to listen to a surveyor try to explain how it is that you, maybe design, a culvert ditch, profile, how it is, can't think of any specifically good examples of what I'm trying to say, is other than what I'm saying is that I'm an engineer, a surveyor as well. And I've done this stuff. I've done this kind of work for 40 years and 38 years. And, so I may have a little different appreciation of maybe a different approach to a solution than what you might get out of Carlson. So please keep that handy, keep that email handy. My phone number is also included in the bottom of my emails to you. So those you have access to anytime, and please feel free to use them. You're not bothering me. Sometimes you may not get an immediate response like today when people call, they're going to go straight to voicemail, but I will get back to everybody when they come in. So just make sure that you keep that handy. All right. Now, a couple of other things in the book. You may see a couple of icons in the margins, and this explains what those mean. There's one that this is IntelliCAD, that one's AutoCAD. Here's a good idea type or something to take note of. Okay, so a couple of things now. And this basically says in this section over here, the way Carlson software works as it sits on top of the CAD engine. We've talked about that already, because everything that it does, it's still just a drawn entity in the CAD file with the data living external to that. Okay. So we're going to talk about, a couple things on how the settings control what happens. Because a lot of people, I've known people that have used this software for 10, 15 years, and they'll stumble across something here that should be fundamental. And they'll say, well, I never knew that. I wish I'd known that, 5 years ago. I could have saved all kinds of effort or whatever. But there's a couple of things. Now, we won't spend as much time doing this like we do in the fundamentals class. But just a couple of things I'll refer you to, and you can look at on your own time. And in particular is this page 5, when it talks about page 4 and 5, this organizing your work. And there's basically 3 methods of where things go. They either go in a project folder setup that you define, like this right here. You can create your own set of folders, and that gets created every time you start a new project. Or you can go the way it is by default to the drawing folder. That means that it's going to start looking for data files and settings and such in these locations. So our startup project folder, our current project folder, current data folder. So if you have the default set to be drawing folder, that means that by default, it's going to start looking for files in the same folder that the drawing is in. But as you can see, as an example here, you're able to put things, let's say you put all your center lines and profiles in a folder called alignments and profiles, but you put surfaces in a folder called surfaces, and it could be in subfolder, subfolder, subfolder. All of that's completely customizable. So, so then what that means, you might be working on a, excuse me, on a file called, site design.dwg, and it's in a folder called client A project And that's where your DWG file is. And then you say, all right, I want to save a center line. Well, it's going to open up the dialog box to say, do a save as, or to go save. And it's going to jump down into, say, a different folder if you're using this. So it saves you from having to navigate away from the drawing location folder all the time. And it can go in specifically segregated folders if that's the way you want to do it. Okay. But by default, it just goes by default to the drawing folder. And even if that's what you said, you're not restricted to that. You can always navigate away from there to a different location, just by using the browser. Okay, so if you want, that's available. The other one, fixed file, is it's going to start always at a specifically named folder location. And no matter what project you're working on, that's where it's always going to go to, whatever you assign it. Right. So look at that on your own. And it tells you how to go through that if you need. Now, there's a couple of settings. There's one that I want to take a look at. I think if you're using 2022, I think they fixed it. So Will, I'm not sure, you were using 2021, I think you said, and it might be fixed there as well, but I want you to take a look at something for me. We'll come back to that in a minute. So if you'll go ahead and load up your Carlson software, we'll take a look at a couple of things I want you to look and see. All right, so it's going to come into some type of a startup screen that looks similar to this. I'm just going to say new drawing, and I'll say next and finish. And then you may see this startup drawing wizard start, and that's okay. Just go ahead and hit the exit button. We'll go over that in a minute as well. So what I want to take a look at that I want you to check, because I'm not sure which version level they may have repaired it, and it's really in the IntelliCAD version where it has the effect. So Pete, yours you won't have to worry about. And Chimizi, I'm not sure if you're using this on top of AutoCAD or on top of IntelliCAD. But if you're using IntelliCAD, take a look on the settings menu. Let's go to the settings explorer. And over in the left-hand side, if you'll open the general tab, now you may have to scroll down to see it because all these may be open, but open up general and then find points and open that up. And you want to look at draw, locate points. And then over in the right-hand side, there's a decimals setting. And this column called values is what's currently set. The column called default is what is normally set. Now, one or both of these might be in yours a particular value that says LU, trying to find it, so I don't have it shown here. Yeah, here it is. Under decimals, so the default value is called LUPREC. And that stands for linear units precision, and it's the number of decimal places that is set when you run the CAD units command. You tell it how many decimals you want. And so that's LU precision. That's its default value. Now, the IntelliCAD version, although it allows the LUPREC system variable, and it doesn't create an error, but it doesn't use it. So it really became undefined. And so we had to go in here and change that to a specific number instead of just leaving it at LUPREC. That's why now it is by default 3. And here it's set to 2. So what that will do is anytime you read out if you create a point and it shows its elevation values, it's how many decimal places do you want to show in that value. So if you take a look at say right up here, see there's a point number, an elevation, and description. Well, that number really is like 199.97 or something, but it rounds it because it was set to, so instead of this 234.56, that would say 235, unless I made that correction, right? So just make sure it has a specific number in the value column, or in the value column. Now that number does not affect things like your CAD units, but just when you're doing draw locate points, and if it were to create a point object as to how it labels the elevation. All right, so that's a setting to look at. And there's one more that I want you to take a look at. I'm going to close this off now.
But just a quick question, Ken.
Yes, go ahead.
In regards to that Carlson Settings Explorer, is there some sort of like a reference? I mean, that Explorer itemizes every imaginable variable default. I've been through this thing dozens and dozens of times. I mean, is there some sort of an overall reference manual or something that Carlson offers that would identify?
No, not specifically, other than, I don't know what you're asking. Let's take a look at it again here. The Settings Explorer. This is all of the different settings in Carlson, and you can see it's generally organized by module. So here's civil, here's construction, Carlson field, geotech, GIS, et cetera, general, which, proper programming techniques, I would have put general up at the top, but regardless, these are all here and they're shown. Let's take a look at, say, civil, and you open that up and you're going to see 3D data, and then you're going to see all of these different, they're basically commands on the 3D data menu.
Right, but I mean,
Okay, all right, yeah, all right, bear with me. Okay, so these are all of the different, and you see some of them only have like 2 things.
Right.
Some of them have, huge list of things. Here's one that's, won't even fit on the one screen. Okay, so what this does, and you can, filter this or find for something if you know what it is. Now, so this is just one interface. It's not used very often. Okay, but here's what it all boils down to. These are settings that are set for every command in the software and every dialog box and every particular thing that you're going to use. And you can see, for instance, the center line. If I want to say draw a center line file, well, this is a little dialog box up, and it comes in and has a center line layer, whether or not you want to draw the PI lines, what length to make them, whether or not you want to label the center line, and if you do, whether or not you have a particular settings file that controls the labeling. Okay, so that's 1, 2, 3, 4, 5 things that correspond to that one command. And so that Explorer, the settings Explorer, lets you dive into all of that without having to do, look through all the dialog boxes. Now, here's my advice to you though, because again, the short answer to that was no, there's not a written document that explains what all those are, because, they're shared throughout the thing, because there's close to 65,000 in some different settings. Okay, it would be a book that would be hard to keep on your bookshelf. All right, so, but my suggestion is this, because those are the same settings under this Explorer by category in one little interface that you get throughout the whole software by things like draw centerline file, or let's say, let's look at our annotate defaults for a minute. Well, this has, I don't know, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, let's call it 15 on that one tab. All of these on that tab, all of these on that tab. Okay, so there's different settings, but notice down below at the bottom here, load and save. This is really helpful and really good to keep in mind, is that whenever you get these, now sometimes it takes a little trial and error to get things the way you want them to be, but once you do, save and load. And sometimes you've got to say things like, if Mississippi DOT is like Pennsylvania, they have certain text sizes and styles, like we have to use, we're going to have no text smaller than 1/8 of an inch, which is 0.125. So this 0.08 of an inch, which is nice and tidy and looks good, we have to have it pretty clunky because they like to half scale microfilm their plan sets. And they also have a thing like existing stuff is drawn in italics and proposed things are drawn in vertical text. So you can set all this stuff up, save it, and call it, say, PennDOT or Mississippi DOT, whatever, settings for a particular command. And then you can switch back and forth depending on what kind of job you're working on, load in something you've done and saved. All right, so that's my advice on the best way to sort of keep track of those and to where those particular settings go. And if I say save here, you see where it's looking by default is in my folder called Carlson Project /settings. And here's some subfolders in there. I can put it anywhere I want, but that's just where it looks by default. And so I can always have one central location, go back and find those things. Okay. If you look at on the settings menu, Carlson configure. Now this has a number of things like general settings, and we'll talk about these in a little bit. The different folder setups. We won't spend a lot of time. I'm just going to show you some of the things that we should set to match our settings. But if you do a save as, for instance, on this, and I'm going to put this, well, I'll just put it here, put civil training in my settings. Now say save. Now I want to show you something. When I hit save, it's going to come up and say 72,191 settings were saved, because that at this level goes through and saves the entire system. All of those things that you saw in that settings explorer. So there's 72,000 settings that are stored in that file. Okay. I've got, let me see here a second. Oh, Jimmy, you said the firewall will not allow you to download the file. You'll be back, okay, you're back. Did you get it? I'm sorry, I didn't notice your chat message come up. I see it now. Were you able to get the file?
Yeah, the file is there. However, I got the email and stuff, but couldn't download it because of some firewall issues. So one of our IT guys is actually helping me right now with that.
Okay, all right, so
Yeah.
we'll, yeah, so, yeah, before we load up a file, I'll check back with you to make sure you have the sample files, because you will need them,
Okay, okay. Sounds good, sir. Thank you.
you bet. Okay, so, anyway, so that's, so Pete, again, the short answer to that is no, there's not anything published on that, but that's what that is a one-stop shop to look up every setting that comes out of every dialog box for every command in the software. So that's just an alternate means of doing it. You can look at it there, or you can go back and say, run a command. Let's look at a command called create profile from layers. All right, so it's not really much. What layers do I want to take things from to generate a profile with? Or if I said, let's say, draw a section file. Still, there would be a list of files. Try to find you one that would work. Yeah, let's say if I draw, let's draw an arc, 2 tangent chord length. No, that's not a dialog box. That's, although it still is a value. Let's say, let's do triangulate contour. No, that'll be a bunch. So instead of trying to go through that settings file and try to figure out where the command is and open it up and try to figure out, because it's just a list of fields. If you look at the command, just go ahead and run the command and look at it in context and get them to be whatever it is you want them to be. Save your settings. Okay. Load them up later if you want to reload them. If you don't know what a setting does, now that may be getting back to the original question a little bit better. Like you want to know, is there something that's documented as to what these are? There's not really, but like, what does it mean to draw triangulation faces? Okay, so nearly everyone, I'm going to say nearly because not all, but nearly every one of these command dialogues also has a help button. And if I click that, it's usually, and again, I'm not going to say all because there's a couple of exceptions, but it usually is context sensitive. So it goes to the right command. So it goes to triangulate and contour, and it's, as you can see, very extensive. Okay, and so you just have to go down through here. Now we looked at that triangulate tab, and we were looking at what does it mean to draw triangulation faces. Well, you just sort of have to, find your way through it or go over here and do a search and index. But so right here, we see what to draw the triangulation faces. That means it's going to draw the triangulation using 3D face entities. And then you can use them with hide and shade and 3D viewer and all that kind of stuff. Or here's what it means to show to draw slope arrows. Okay, so usually they'll have a help system in all of those things, and it's usually jumped right to the command. Sometimes it doesn't, sometimes it'll jump to this or whatever this may be is whatever is left at. Well, then you may ask yourself, well, I'm in the civil module and I was in my, say, 3D data menu, and I wanted to see what edits or set polyline to elevation, or let's see, polyline elevation editor. That's the command. So sometimes you might have to go through and, sort of dig your way into it, but it tends to be organized by menu. Okay, so this is very precise control on that 3D editor. It's a very, very excellent command. and a couple of other nice little things here, and I'll repeat this at the end of our time tomorrow. But there's a really good section in your help system for some tutorials, some CAD basics, and some different survey things, modeling, a dozen different tools to design surfaces with, okay? And they'll step you through some of these. Now, some of them aren't necessarily the way I would do them. Okay, so I will probably be showing you a couple of nuanced variations or complexities of some of these that you see, but they're excellent little exercises to go through. And all of the files, when they show you, say this one, that file is in your delivered software. It's in your Carlson folder, or your Carlson projects /settings folder. And that's called what, this example 2-ex. So all of those things by default are, this example 2.dwg. It's in Carlson projects, not in settings, but in Carlson projects. So if you took the default when you installed the software, you'll see those files. They're there. That's an excellent way to learn some of this. All right. So now, the next one I wanted you guys to take a look at, and we're going to stop and take a break here in just a minute. But the other setting that I wanted you to look at, and this came about in this very latest 2022 upgrade. So, Will, are you still here with us? I know you've got to jump in and out.
Yeah, I'm here, Ken.
I want you to take a note of this. If you guys do update to 2022 at some point, double check this setting. If you go to your annotate menu and choose annotate defaults, on the distance tab, I'm gonna change that for here now. Let's see, put it again. So if you choose annotate defaults, on the distance tab, right here, there's a thing called decimals. This is how many decimals do you want when it's computing things like distances, like on a meets and bounds, bearings and distances along property lines, or if you just annotating it like a center line distance, whatever. You can choose this AutoCAD units. Now that will honor, even though it says AutoCAD, it will also honor the IntelliCAD, and that is the LUPREC type of thing. It reads the units, whatever number of decimal places you have set in your CAD system, it will use that instead, or you set it to something specific. Now, what happens, and what it used to be was, this was what most people had. And I want to see it to the nearest hundredth, right? But at some particular point, they updated the software to include these. You see the 0, and then it went to 0.5, then 0.0, and 0.05 or 0.00. So you see the halfway between values. Well, when the last update happened, it set this to this value instead of what I had before, which was 0.000. Now, what that 5 does is it rounds it to the nearest 5 hundredths. Now, why, as a surveyor or even as an engineer or anything else, would I ever want to set my distances to the nearest 500ths? I'll guarantee you what happened is that some company somewhere called up Carlson and said, hey, you know, it'd be neat be neat if I could set that to the nearest 500s, because that's why we like to do it. And so the programmers dutifully did it, but they, instead of keeping what I had here before, they changed that to be that value to the 0.05. And you don't ever know it. You don't recognize when it happens when you do things like where these take effect is under auto take. You might say under, let's say, put a bearing and distance along a line. And we'll just go from here to here. So that's where that value, that number of decimal places comes into play. So you're and it stays whatever it was before it was supposed to. And that's why, you know, I wasn't aware of the fact that it changed. And it's got this, it had that text style was changed to say magic text, which is not really a style. And I think what happened was the programmers were testing it out and they had those settings left, and that's what they set everybody's system to. So so now instead of having that, instead of like 739.03, that would come across, if I had it set to 0.05, it would say 739.05. Okay, you see how that works mathematically, but you can also see what a nightmare that will be to a surveyor, because it's not a very big distance. But even if it is, I'm going to draw a line. I'll draw it from here, and I'm just going to go, or I mean a polyline. I'm just going to go, I'm going to go a distance of 500.03 feet. Let's go toward the cursor. All right. And let's set. Let's get that up a little bit better here. And if I had this set the way this had changed, make sure there's so you got the same thing here. If you choose degrees, minutes, seconds, it doesn't do any rounding, but if it's on other, you can do the same thing. You got these round off values. Or you can round to the nearest 15 minutes if you choose this. You know, so you got to be aware of these, and the fact that they changed it without telling anybody was a real nightmare. I've got a client who's a surveyor, and his plats were not working right. So I've got that distance, remember, was 500.03. So now if I said, all right, I want you to annotate that. Whoops. One more time. Bearing distance. There we go. On 9 volt. Okay, so if I am a surveyor and I put somebody's property line information on my plats, it's going to say 500.05. Now, if that were 500.00 exactly, that would read 500.00. So it doesn't look to be an error. But here's the case where it's just over 500 feet and it rounded it up Of course, if it was 500.02, it would go down to 500.00. But if I look at this, if I select that item and look at my properties, I see that it has a distance of 500.03. So he kept trying to figure out, when he finally got around to noticing, he kept thinking something happened that changed his geometry. Because he's constantly tweaking those things based on points that he finds out in the field, and whether or not he's going to hold a particular point, or whatever decisions are made by the land surveyor, and he couldn't figure out what was going on. And it never was a problem until this last update. So he caught it, brought my attention to it. I've sent it up to Carlson as a request to investigate and let us know, and I haven't heard anything back on it yet. So it seemed to be an oversight that was problematic. So just those two things that I've just shown you, that LU Precision for the IntelliCAD version, and this on the annotate defaults, if you have updated to the latest 2022 update, you need to verify it is what you want it to be. So if you want it to round to the nearest 500ths, then by all means do that. But there's no particular reason to do it. In my type of work. And so now I'm good. Go ahead.
Well, I just Ken, I just wanted to ask how you turn on the annotate, the labeling on this annotate tool, because mine doesn't even label it, the polyline like how you have it.
Okay, you have a polyline there.
Yeah, I do.
Okay, did you let me have you share your screen.
Okay. Okay.
Okay, I think I'm going to stop my share here. So now go ahead and share your screen.
Okay. By the way, I got that data downloaded.
Yeah, I saw you had the book open there, so good. All right, so let's take a look. I will request remote control in case I need it. I don't know that I will.
Okay.
But let me take a look at this first of all. Let's see here. All right, so this looks like just under 400 feet.
Yeah.
All right, and now let me take a look at your drawing scale. It's 50 scale, 08, so that's okay. All right, so it should be showing. Okay, you're using AutoCAD. Okay, so now show me what you did to get the bearing and distance on, or did you?
Oh,
Run-
okay. I thought you just get the distance. I just do this.
Oh, I see. Okay, you actually work. Okay, yeah, it's not just report the distance.
Yeah.
You're needing to generate the text. You need to annotate the text. So let's look on the annotate menu.
Yeah.
So if you go ahead and pull down the annotate menu, and now let's go ahead and look at your annotate defaults.
Okay.
Click on the distance tab. And now your decimals are set to AutoCAD units, and that's fine. Okay.
Yep.
So, and now you know what that means is, I'll go ahead and hit cancel there. So we'll leave that set as it is. But what that means is if you type or if you run the units command,
Okay,
it's this right here. So it's going to be 4 decimal places. Okay, so if I select this and look over here at its properties, I see down here in the length field, it shows me to 4 decimal places. That's fine. That's what I want. If I leave that annotate default, now go back to the annotate menu.
okay,
And so that's all you did was set the default. So let's come down 2 lines and choose. All right,
okay,
so there's a default. Leave it like that. Now go ahead and close that. Now come down from annotate,
hmm,
go back to annotate and come down 2 right there and then go right and choose bearing underscore distance. That one right there. There you go. Now just select the line or polyline, just pick it. You don't even have to you don't snap it, you just pick it. There it is. Now, and go ahead and hit enter, you're finished. So there it is. And you see that it used the number of decimal places that you have set in the units command. So likewise, if you had, say this. Now, again, where that takes an effect is right here. You see that number of decimals is way out there down here on the length. And if you annotate that again, let's just choose bearing distance. See what it did?
yep,
So it responds to that. Now, if on the other hand, your auto annotate is set to be a specific number, like 0.00, and 0.05 would round it up. So now if I repeat that bearing distance, it's going to show me 2 decimal places. But when I select it and I look at my properties, I still see those AutoCAD units set up over there.
okay,
So, and neither one is right or wrong. It's just a matter if you want them to be like a surveyor would typically do it, would typically show it to the nearest hundredth, because it's hard to measure something any more precise than that when using a tape. Obviously, we can measure more precisely than a nearest hundredth with modern laser type distance meters, but not a whole lot tighter because of positioning and centering errors over top of points, but still. But that's where that comes from. So now, even though as I select this, I still am back to my 4 decimal places, but when I annotate, it's going to show up as just 2 decimal places. Now that's 9291. So if I go to the nearest 5, watch what here's what I was having you change.
Yep.
Is if on the distance tab, it is set to that. Like I said, I don't think my AutoCAD version did not have this problem. It was just the IntelliCAD version. But if that were there, and then I did that same bearing distance, see that how it ticked it up, okay, to the although really it should have, if it's going to go to the nearest 0.05, 9291. Well, yeah, I guess if it's over 925 and above would tick it up, 9249, whatever would tick it down. So it'd either be 90 or 95. So again, it's one of those things that, it caused a real problem for a client, and not a lot of them necessarily noticed it. And, so how many plats got recorded in the courthouses with the clerk of the circuit court or whatever is done in your location, incorrectly, because you can't see that difference. And if you don't go back and double check and compute closures based on numbers, and even at that, it may still close within proper parameters. It still might be too much. Okay, so
Can I ask you a quick question, Steve?
Yeah.
Ken?
yes.
Ken, if you annotate this line, for example,
Mhm.
you may go kind of like window in, you have your annotation all set up. Is there some way to kind of lock these bearings and distances in place and preserve the integrity of these values? Because if you wind up going somewhere later on and you wind up editing this particular line, that annotative distance will change to accommodate the new line.
Yeah.
Is there some way, once you annotate, to kind of lock those values in?
Yeah,
Make
couple of
them
things, like right here.
right.
Um,
If you were to wind up
Now-
breaking that line in half or trimming a piece off, of course, those values are going to change.
yeah, see what I'm doing here?
Right.
So those are all updating and changing. Now that's also due to another setting, but let me make sure I'm on the right thing that I want here. Yes, okay. But now here's what you can do. You see that it's on a layer called C line.
Yeah.
Well, you can do once it's there, if you go to that layer and lock it,
And lock it.
yeah. So now it's locked. And so now if I try to select it, see, it doesn't even give me the grips. I can't do anything to it. If I say,
I'm not talking so much about the line. I'm talking more about those annotated values. If for whatever reason, midway through, you would need to kind of use like a break command or something just to
you mean, so if I needed to do something like this, if I needed to say, pull this back.
right, for clarity of for
Yeah.
hard
yes,
copy
yes,
purposes.
let's say I needed to knock a chunk out of this like this. You don't want that to update. You want to keep it.
Right. I don't want that to update. Yeah.
Okay, so yes, the answer there is yes. And what you do is this. You can either see that's on a thing called bearing text, BRGTXT. You can either put that on that layer and freeze that layer, but that's not what you really want to do. What you're wanting to do is this. I'm gonna go to my settings, my Carlson configure. Now we'll talk about this, all these other ones as well. But under general settings, it's right here, link labels with line work.
Ew.
If that's unchecked. Now, if I annotate that. All right, so there's my annotation. And so now if I break this thing
Right.
from here to here, or even if, I bring it all the way down to here, or even out here, you see that stays exactly where it is at the time that I annotated the original.
And where was that again, Steve? I'm sorry, Ken?
It's under the settings. We'll talk about all these here in a minute. I want to make sure you guys get your break here, but it's under, sorry. It's under settings, Carlson configure,
Carlson configure.
general settings.
Oh, general settings. Okay, okay.
And it's this right-hand side, this little box here that says.
That object linking.
linking.
Okay, okay.
And you can see the different ones. You can link points with the coordinate file, link line work with points, link line work with center lines.
Right, right. Perfect. Thank you.
We'll talk about those in a minute when we come back, all right? But I want to make sure you guys get your break in because we're going to run into lunchtime and nobody's had a chance to get up and go to the bathroom, although I know you guys will probably do so if you need to. I hope you will. So anyway, let's take our 15 minutes that we get. We're a little late because we got started a little late, but let's go ahead and do that. So it's now 7 minutes after. Let's take 5, 10, 15, so 22 after. So thereabouts. I'll be back at 20 after. We'll see. Now, when you come back after the break, just give me a thumbs up. I'll check and see it. But I'll propose or I'll pause the recording. That's the biggest thing. I did that on one class where I went for like 2 hours before I realized I didn't turn the recording back on. So I've been really careful with that lately. So now, anyway, all right. So we were going to talk about a couple of those things, that linking, and one. So let's all go to the settings menu and choose Carlson configure. And go to the general settings. And if you would like to match what I've got mine set to be, feel free to do that. The only one I would tell you about is this one right here that says use software rendering. Leave yours unchecked. The reason I have mine on is that I'm running mine on a Macintosh computer and I'm running through a emulation of Windows. It's not a true Windows computer, so it can't get to the graphics card. It has to use software rendering on mine. But yours, you'll have better performance if you uncheck that. Now, over here on the object linking, let's talk about that a little bit. These are things that if you want them to be linked, and Pete, in your case, you wanted to know how to make that not happen. Well, that's how you make it not happen, is you uncheck that labels link. But then if you do change something and you need to re-annotate it, you just go back and re-annotate it. That's
Right,
not
right.
a problem, right?
Yeah,
And-
there were many times where halfway through the drawing and, all of a sudden you wind up looking at some bearing because
Yeah.
edited the line for whatever reason. And, that value changed.
Yep.
But lucky to have caught it, as you say, with these erroneous filed mappings, with that,
Yeah.
with that rounding value, these things do happen. But
Yeah. And it's
this is big. Thank you.
right. And it's particularly sensitive to things like bearings because you might be reporting D bearings instead of the actual geometry bearings because you might be in state plane versus, being on the
Right.
rotation of the deed. So that's where you control that. Now, other things like this linked line work with center lines, that's one that's really helpful. If you do this, I'm going to say okay and then exit. And I'm just going to draw a 2D polygon. I'll go from here to here to here and to here. And I'm gonna put that back to that and see what my NSLT scale is set to. It's on. Scales 1. Let me see what this.
What was that command? What was that?
That was on the inquiry menu that said draw.
Oh, the
new
inspector? Oh, yes, the inspector, okay.
And I just right click and shows angle distance.
Huh.
Of course, I've turned it back off. Let's see, angle distance. All right, so now. There we go. So, so this is what's neat about having the center line linked, line work with center lines. Is if I turn this into a center line, I'll go to the center line menu and choose polyline to center line file. And it's wanting to know a file name. I'm just going to call it junk. And I'll just select that. Now this might be, you know, a sewer alignment. It doesn't have to be, let me turn off the inspector. It doesn't have to be a roadway, but it could be a roadway. So now, because that is, even though I look at it in my properties, I see it's just a polyline. But if I, let me draw another one over here. But I won't turn that into a center line. So now, if I double click that, it's going to come down here on the bottom of my screen and it's going to run the edit command. If I double click this one, it's going to load up the center line editor. And I could go there, say fit a curve of, let's say a 50-foot radius. And if I say save and exit, notice it updated on the screen automatically. If I didn't have that link on, it would not have done that. I would have to erase that and going back to centerline and say, draw the centerline file. Okay, so you may want it to behave that way. That's fine. But I can also do this. Let's say I'm going to just do a simple fillet. I'll do a radius of say 40 feet. And I'll pick these two pieces. So that was just a standard CAD fillet command. But if I look now at that, I'm going to edit the, I'll go to my centerline editor. I'm going to load up that file called junk. See that circle, that curve? The 40-foot radius. So you see it's a two-way link. Even if I just go through here and grip edit the polyline, it's going to make all those changes in both places, both here on the screen and in the polyline definition or the centerline definition. Okay, so that's what those two things will do.
Can I ask you one question, Ken?
Certainly.
So say we're in Carlson configure, we just made changes really to any of these settings, but specifically we just did in the general settings.
Mm-hmm.
Okay, we close, click OK. How do I make sure that the settings I make here apply to all drawings and not just this drawing? Like when I load up a new drawing, do these automatically apply, or do you have to set that somewhere?
No. They will stay in effect until you change them again later.
So anything you do in Carlson configure applies to any drawing you do, any new drawing.
Yeah, there's one here under this drawing setup. And this is where you're changing. Let's say if I make this 100 as my horizontal scale.
These are just drawing specific settings here, though.
Well, you watch what happens when I say okay and exit. it says, aha, you changed the drawing setup. Do you want to apply that to the current and future drawings or only to future drawings?
Okay.
So that particular one recognizes that you might just be setting defaults, but you want to leave this one alone. Okay, but generally, anytime you make a change, and even when you do something like, look at this command, quick profile, it's pointing to a surface file and it's looking at a surface file called, this 3D machine control class getting started eg-good-3.10. So it keeps that same file in this dialog. So you would need to then, go over here and navigate to a different file where you're working instead. Okay.
So do I even need to save those settings? Like down there, there's a save as.
Yeah. Well, in that particular one, yeah. See, this one doesn't have a save and load on it. So in this one, you just need to, keep your eye on that to make sure, because let's say we leave it at that, we'll say, okay, it's going to prompt me to pick a starting point. So if I go here to here and hit enter, it's going to try to, but it says it didn't find any points because I wasn't over top of where that surface is in the world. I would have to be in the same coordinate location. Okay. So if you get something that behaves like that and it tells you it didn't find any points on a command like that, because it's looking for a surface file, it's looking for that last set file. But all of these, if you look under the surface menu, triangulate and contour, whether you draw the contours or not, whatever layers that you might have things set to, whether you have any filters in place. So you always just sort of either need to, take a look through these the first time you run the command to make sure it's going to be what you want. And if it is something, and if it has a lot of settings that you painstakingly set up, if there's a load save button, consider saving those settings so you can load them back, and it puts everything from every tab in this dialog box. It will fill it out based on whatever those saved settings were. Okay, so kind of get used to looking at the bottom of these things for those two load and save buttons, and they can save you some time, because if you go through all the effort, let's say if I'm going to draw, let's see, if I'm going to station polyline center line, you've got distances, you've got layer names, you've got styles that you may use, layer names up here, text heights, particular markers that you might use for the different components. And it gets to be, a little bit tedious on the first time you set it up. So if that's the case and you got things exactly like you like them, and they're really more prevalent in things like when you draw, like if you draw a profile, and if you add a file, let's just do this one, then see there's all kinds of settings in here, and road profile labeling, sewer and pipe labeling, pipe crossings, laterals, utilities, how to draw the grid, whether or not you want to set it up into paper space layouts or in the draw or in the model. There's so many different things that you can set. So they're worthwhile getting set up exactly like you like it, save your settings, and then choose OK. And a lot of times when I do this on a production job for a client, so even though, I may have a particular scale and vertical exaggeration that I'm going to be using to draw this profile with, and different text and symbols and colors and layers and line types, all of these different things. And I may choose OK. And let's say if I do choose OK and I go out here and I choose OK. I don't have it let's see, I forgot what profile I used. Well, anyway, I had to match it up to a center line. I don't have this set up right now. But so what happens is I would draw that, take a look at it and say, that's not what I want. I want something different. Just repeat the command. Say draw profile. And there it is under Carlson project, center line 1, layout 1. Okay. And then you go through here and you change. Well, instead of having this at a, say, a 20 scale, maybe I want it to be 50. And that to be 10. And then you try that again. Now let's see if it lets me. What was that? Center line 1. There we go. All right, so that's trying to put it here. Let me set this up a little bit. So there you can see where it started to draw the profile. And it needed a match line. So here's the first one. Let me do that same. So you can see it. So you see there's my vertical curve, all of these defaults. And so let's say, well, that's not how I like it, or I want to have a different offset into the page. Then all I would do is go back and run that command again, draw a profile, make some changes here. And now instead of, what did I, where are my offsets? Let's see. Lower left offset 0. So let's make that I don't know what it is. Let's make it 1. So you see what it does, it goes back and it clears out what it did before. And well, I didn't get the offset managed. Maybe I've got an offset here going on. No. So anyway, so that would be what you would typically do. Go back and just keep doing this until you get it the way you like it. It clears out the old. So let's do our pick. See what that does. That'll shift it. Horizontally. I did not do the vertical shift. Anyway, you would get all, so like I said, it can be a little tedious in getting things set up the way you want it to look. Or maybe even you decide you don't want to do them on the paper space. You just do it in the model.
So Ken, quick question though. So when you did this offset right now, did it change the axis of the drawing? did it also offset the axis of the drawing on the layout page?
Did I, what, on these?
Yeah, did it change the axis?
No, it's just where it starts and stop, where it starts. So if I. Well, here now, instead of drawing it on the sheets, I decided to. Whoops, see what. Okay, so that set it up there. Now I could do that and then go over to something like this and put in a viewport. Oops. And it could be, wherever I wanted it to be, and then I can. Reposition it and do whatever I want with that particular viewport. Maybe bring it down like this, and then I can move the viewport, to a different spot on the page. So, that's doing it from, say, here. Whereas if you want that to happen automatically, you don't even need the viewports. You could do this. Let me draw this in on the file. All right, so there's what that looks like in horizontal layout. And then if I draw my profile, keep the same thing. I could draw it here in my sheets paper. So I'm going to put it in paper space, add the layout name to the file for drawing output. And so use the template layouts. All right, so my sheet width is 32 inches. You can set different attributes. You can give it a specific name. If you have a template for it, you can, let's see, let's lower left offset. Let's make that, say, 5 and 5. Set that up to a D sheet, make a PDF. Whoops, sorry, hit the wrong button. And right now it's plan over profile. Plan profile gap. So where does the plan sheet start? Lower and upper. I can just pick that and now choose. So you see what it's doing is I put in that 5 and 5, and it's starting the profile 5 units over and 5 units up from the corner of this frame that I drew in here. Okay, so I'll just pick that and pick that as well. Now, what's going on here is if I look at that coordinate, it's at a location of, if I look over down here on this bottom, that's at a location of -100, comma, -145. So that's where it's putting this sheet. Okay, so, but what I really want And it's also that 100, 145. So what I really want to do is make sure I can get this stuff to fit within this frame and have that frame centered on my layout tab. So if I go back now to draw profile, let me set my reference center line so I don't have to keep picking it. And I say, okay. In my setup, my sheet width is using this block. I could select a different, so there's profile 2. So you can have different sheet sets. Use that one, open that one. I'm going to set this offset to be back to this 1 and 1. So now what's going on with this is a block. See up here? It's a block reference called profile 4. Now that block if I double click on it, it's going to show right here. Let me edit that block editor. And if I look at that location, that's at -2, -3.33. So I could do this and just move it from here to 0, 0. And if I save that, and then you see how it's scooted it up inside the sheet boundary now?
Yeah.
Okay, so, and at that point, I would then adjust these offsets. So it needs to be more than 1. I need to figure out, what is that distance here? $56.25. Again, goes from see. Uh, yeah, see, it puts that in at a scale. I normally do mine at 1 to 1. When I create mine, I do them 1 to 1 and I put them in there so I can always measure these as inches. So anyway, the bottom line to all of that stuff is that we're going to you wind up see where there's some place where it says to draw at 1 to 1. Here it is. Plot at 1 to 1. 0 to 0. And now my offset here would be, let's just say 1.5. Yeah, all right, so we're now, not quite. Like that. 2 and 2. Maybe 2.5. 1. So now, so there's my match line. At station 16 plus 0, 0. Because it at that scale, and over there is my north arrow. You know, move that around. And you can set all those controls up. So here's my plan view. And I should probably consider doing that. Because see, that is a viewport. Probably need to consider, setting up, making that gap a little bigger when I draw it, so it looks a little bit, keeps these a little bit offhand. Now these lines here are part of that block, but these lines come from this draw grid part. Okay, so if I didn't draw the grid, I would only use the grids that are drawn in the block. And that might be what you want to do. All right. But anyway, the bottom line to all that is when you do this stuff, and again, you might set up, the layer that this goes on, that's on Windy Acres storm profile. So I would probably want to put that on a different layer. So I would set all that stuff up, and then once I had that, and you see, I'm just doing this over and over again until I get it like I like it. And then once I do, you can save this set, which saves the center line and profile, and you have multiple profiles. And also when I come here, I would save settings and load settings so that when I wanted to bring this back up, it would fill out, the scale and all of these settings that are in here, so that when I'm ready to draw this stuff for real, I can do it as part of this. Yes. Jamisa, you had your hand up. You're muted.
Yeah, so one of the issues that I've always had with this, with drawing grids like this is, this geometry, they come in, like the grids itself, it comes in as single objects. For lack of a better name, I'll just call them geometry objects for each line there. And let's say I wanted to zoom in on that without necessarily zooming on the grid sets to fit the viewport, without necessarily moving the viewport. I've always noticed that, like for instance, the labels themselves, they annotate, they actually move as I do. They actually wouldn't move with the zoom in just on individual. So
Yeah,
on
like
individual line.
Yeah, like this up here.
Let's say if I wanted to I'll say scale, like manually scale, like select them and be able to manually scale to fit into the viewport. Like, is there a way to just like grab each end and just resize them? Like I would just resize a picture.
Oh yeah, you mean like this? Let's see if you
Yeah, but for the entire drawing.
Yeah, but you would do it, say here, and you see right now it's set to a particular scale.
Yeah,
So instead of 30, let's say I made it 40 scale or I
okay,
made, 20 scale.
okay,
Or, you know, I could, you can just do it with the wheel on the mouse. But now there's two things going on here. I've got a plan view drawing and I've got a file view drawing. The plan goes in a viewport and that viewport gets generated such that, now in this case, the way I drew it, the end of it had to come on out here to finish. But if you wanted that to all fit into a single viewport, you would have to, you know the scale, you measure your paper, make sure that it can fit within. And in that setup,
mhm,
in paper space, you would say, let's see here. So you draw the plan / grid to the full sheet width. Draw profile grid lines, yes or no. Draw the grid to full sheet height, so go all the way up. Down here, if I fit each vertical, let me see if I tile the sheets. No, that's going to tile out here to the side. See, what happens is it tries to draw it like this, okay? And you know, at 50 scale. And so if I did that, that's what pushed it out there to that second sheet.
mhm,
So if I didn't want it to do that, I need to figure out what this offset needs to be. So I went back to my sheet setup and I know I've got a 32-inch wide sheet of paper and I've got this 2 inches lower left, 2.5 vertically, 2 inches horizontally. So I could maybe pull that back to say, if I said 0, you see that's not exactly what I want, but anyway, you'll see what happens when it comes up here. See, it has now no particular offset in the horizontal. It's at 0. And that's where this viewport starts at 0. But see, now I could see that brings it all together. And then I don't need to have this little piece of it that went off the edge. So to be able to do that, plan grid to full sheet width. Trying to see where it's breaking. End station, start station, end station. Okay. 32. So if I go from here to here, then let's give this a I'll sit there. Let's see what this will do for us. All right, so that fit everything on that sheet of paper. Because it went to the full width. I still had to bring it back. Now, if I wanted that particular, let me set my text up here. Now, these are all, whoops. I gotta set this up so you can see it. So again, I could double click in here and then, you know, scale it around to make it match. But what happens is that disengages with this setting right here for that horizontal scale. Okay, you can change it, but when you do that, you know, you would have to have some kind of nominal scale. You wouldn't want it to be like 1 inch equals 53.2 feet. You want it to be 50 or 60 or 20 or whatever. So that's what it's doing when it's creating this sheet, is it's figuring out if it needs additional sheets, it will create them for you automatically. Okay, and then, you know, you would see that's not going to position fully within the boundaries. If you consider, say, this line here as the boundary, it's going to be in the margin a little bit. Okay. And now remember, this is a viewport. So it is looking into the model and showing what's in that model. Notice it rotated it a little bit. That's why our north arrow is here. See, puts north up at an angle so that it can fit. And it aligns itself with the profile view at that standard scale. So when it doesn't all fit, if you're doing it to nominally sized sheets, it computes and redisplays and does all that stuff for you to create the sheet at those nominal scales. Okay, but can you rescale those? Yes, you can. Now, this one is a viewport, but this down here is not. These are a bunch of drawn elements. Now, what you can do with that is you can scale that to go from, say, let's go from that corner, and we'll do it by reference. We'll say from that corner to that corner, I want to be that big. All right, but so now I didn't move it. I could have moved it. But see, these are things that are drawn. I'll just copy and set up here. See, these are individual entities that are drawn in paper space. That's a line. That's a piece of text. You see, so those are things that you can scale individually as entities. And you could just, you know, scale them up or down, however you might want it to do it. Okay, but now though, what's happened is I wanted to create that at 1 inch equals 50 feet. But if I see what that distance is from here to here, it's no longer 1 inch, it's 0.85 inches. Okay, so, you know, whereas, yes, you can do that, but that's not really what you want to do in terms of plotting a plan profile sheet. You want that to be at a nominal scale. So somebody, if they only had a plotted paper map, they could pull out an engineer scale and measure distances. Follow?
Yes,
So,
sir.
you know, what a lot of times we'll do, because this sheet that was a block pre-made, but this doesn't have our company name and logo and date and file name and sheet number and all that kind of stuff on it, which you might want to use. So what we often will do, and let me exit that. What we would normally do, or not normally, but what we would often do, instead of doing these, just get rid of these. So what we would normally do, we might put our own sheet boundary in here. But then over here in the model tab, we might say draw profile. So like we've been doing, but instead of drawing a paper space sheet, we're just going to draw it right here. We'll say okay. We'll say okay. We'll place it right here. Now, all that's done is created the this created those same drawn entities that got scaled and placed on that paper space. So we'll set this one up now. And we'll set. Instead of a letter size sheet, we'll use the D size sheet. One to one. And so now, what you would normally do is you would set up your viewports. And let's set, say 2 viewports. I'll go from there. Down to here, and then within this one, I might want my plan view. And then I'm going to say the twist screen. And I'll go from, so let's choose that. We'll get that, send it a little bit better. And now school's quit working there. So I might be like that there, and I would set that to be, so I wanted to match. If I wanted to match that at 30 scale, well, that's not at 30 scale. Actually, what I need to do is set my viewport to be 50 scale. There's my 50 scale. I want this one to also be at 50 scale. So I'll set that there. Okay. And then once I have those set like I like them, I would select them and change them to locked so that I can't accidentally, zoom in there and change the scale of the drawing. It's going to stay what it's supposed to be. Okay, so if our geometry is such that, we don't get all of it, we can either say, well, that's okay. We'll start this at 0 plus 50, and we'll end it out here at 16 plus 50, even though the profile goes from 0 plus 0 to 1750, it just clips it off, unless I want to, open it out a little further. Okay, so but this is sort of a manual approach to showing this plan profile. Now, what you then would have to do is, you see this station 1 right here. I would normally want to say, I want that 1 to line up with 1. Actually, you want 0, 0 to line up with 0, 0 in the profile, even though by the time you get to the end, they're not going to match exactly. But you sort of want those to line up as best you can. So then you would take one of these two things, let's say this thing, and let's move it from there to there. So now you see my viewport is offset from this viewport, but station 1 lines up with station 1, or 0, 0 if we started correctly. Okay. So that's doing all this stuff sort of manually, and everything that's drawn is drawn here in the model space, and I'm just looking at it in my paper through a viewport here and a viewport here. See, they're both viewports. But if we go to our draw profile and choose to draw it, to draw the sheet and put it in paper space, then here's where the plan view always gets put in a viewport just like before, but the profile gets created right here as drawn elements in the paper space, not in a viewport, and it doesn't draw it in the model unless we tell it to do so. And it figures out how best to position all this stuff based on the same starting station, what's their best rotation to get everything shown, whether we need to put match lines in. So it does all that stuff for you automatically, sort of, keep you from having to do all this kind of manipulation. Bring it down a little. Bring it up, now you can see a little more like that. Okay, so that's just a matter of preference as to how you want to do it. And to be honest with you, quite often I do it like this and I put them into my own sheets. I don't have those pre-drawn profile sheets, but I have title blocks and I'll put them in there, and I'll go to that effort to make everything line up the way I want it to do. Just a matter of what fits your workflow better. If you do this stuff automatically, with this business, and you take the time to get all these little settings right, then every time you do it from then on out, no matter which profile you're in center line you're drawing, they'll always have that same look, and they'll fit onto the sheet the way you want them to do. You don't have to go through all this manipulation, but it leaves this plan view, even though it creates it at that viewport, it creates it at that 1 to 50 or whatever scale you say in your profile draw. And then you need to make sure you go back and change this locked to yes, so that you don't accidentally zoom, say if I don't have it locked because it leaves it unlocked, And then if you happen to accidentally be inside that viewport and scroll, well, now I've changed the scale. Okay, so when you do it like that, you got to be careful to make sure that you put this, to yes. And let's go back to 50 scale. And then lock it after you get everything lined up. Okay, does that clear up a bit of the mess? So we're getting a little bit down into the weeds on this stuff. But when you have questions like that, ask me, we'll take a little time. We need to get a little bit more into the design side and how we do the math. And, this part is more of your output. That's a little bit, more drafting rather than design stuff. So, we'll take a look at those when and where we need to, but for now, let's focus back on that. So we're a little bit into our lunch hour. Now I know, Chimiza, you probably, what is it, like 9:15, you're ready for a cup of coffee instead of lunch. But so we're going to go ahead and take our hour break. I will almost forgot to turn the recording back on.
Just forgot.
Okay, so when we model surfaces, our goal is to create a series of triangles that line up edge to edge, and they're pitched in different orientations. Perhaps they're all, in the same orientation. If it's, either a level or a continuously sloping surface, they're all on the same slope. But what we need is a minimum of those 3 points. Now, when you're talking about a job site, for instance, we're going to have more than 3 points on there. We're going to have as many as we need to model the surface. So we go out on the ground, if we're a surveyor, and we start observing those points, like the high points and low points and specific points over here, like maybe the base of a post or something that's on the ground that represents elevation wise and position wise that point on the surface. And so then we fill in all of this missing space in between every 3 points that forms a triangle with that little planar segment. And then they all line up together and form this large contiguous surface, which would look something like this in here. You see, there's a bunch of these triangles that all come together, and taken as a whole, we're going to be looking at them in our three-dimensional viewer, and we can color in those triangles so you can see what that surface looks like. Okay, so that's where we're headed with this discussion. Now, back to that beginning concept. When you have a bunch of points, if all you have are the points, then the computer draws lines. You think of them as 3D polylines in between any given 2 points. And then if that line's drawn, then it goes over to the end of that, and it might draw this point up here. And when it sits here, then it might draw this point, draw this line over here. Now, once these lines are formed, now all this is done in memory, but once this triangle is formed, this along this line, this point over here in the lower right is no longer able to draw the line up here to this point in the upper left, because this line's in the way, it can't cross that. So where it gets this data to form these series of triangles, it looks at points and it looks at any three-dimensional lines, any lines that have elevation. Okay, so what we have to be careful of when we're gathering up our points, let's say all we have are a bunch of points, then take a look at these elevations. Now, what this represents is it says it sits on this point at 110 and it connects the line down to 100. So halfway between is 105. But it also connects from 110 up here to the upper right to 110. So that's level across there. And then 110 connects to 100, 105 in the middle. All right, so that forms a ridge along this top, 110 to 110, drops off to 100 in the lower right, drops off to 100 in the upper left. Well, that's all well and good if that's what really happens, but what if the situation is really like this? These are the same points, but if the triangles get drawn this way first, before this line gets drawn, it draws this line. Now it represents the bottom of a valley or a ditch. It goes from 100 up to 100 and it rises to the left to 110 and it rises to the right to 110. Okay, so those are two completely different structures. This one compared to this one, but they're formed out of the same 4 points. So what we need to make sure we have is, if this is in fact a valley, we need to draw this line in here ahead of time before we tell the computer to look at everything and decide how to draw the triangles. Because if the line is drawn in there ahead of time, it can't draw across that boundary. That's a break line. And really, when you think about break lines, you know, they're called break lines because they represent lines along a break in grade. And that's what they are: valley floor, ridge line, tops and toes of slopes, etc. But what you really can think of them as, and what's always helped me out, they're really nothing more than edges on the surface that we're modeling. So Will, you talked about you used a bunch of 3D break lines to make surfaces, maybe the edge of pavement or the back of a curb or the face of a curb or something. Then what you're doing is you're telling it, okay, that's an edge on the ground. And so we need to make sure that it's an edge in our model data sets. So if you have drawings that already have those in there, then you know you've got everything done. All you have to do is tell the computer to look at it and build a surface from it. Now here's an example of the problem if we don't create the lines that form those edges. Let's say we're a surveyor and we go out there on the ground and we survey a bunch of points in. We get this edge of pavement, point A and point B, and then point C and point D are along the gutter line. And then point E and F are up here on the top of the curb, and point G and H are on the back of the curb. Okay, everybody can see the structure, but all we have are these points. Now, what can happen is the computer could, depending on where it starts and how it starts looking at the points around itself, it could sit on point A and decide to draw this line up to point B. Well, that's fine. It could draw this line over to point C. That's fine too, because that lies along that gutter. But it can also see point E, and it could draw that line, but you can see how that is not representative of what that does. That line really needs to come down here and then up. But instead, because there's nothing in between, now this, you know, we haven't drawn the stuff. This is just what's out there on the ground. So if we don't draw in that flow line ahead of time, point A is able to see point E, and it might form a triangle across there. And that would be a problem. We would be coming down here and looking at this surface in this area. And it would be from point E down to point C, which is correct. C out to A is correct, but A doesn't go to E. So that would hike that triangle up along this edge, and it doesn't do that. It needs to run along this edge and form two triangles, AC and whatever that point is, and EC and that point. Okay. So those are some potential problems. B can see F, C could see G. Technically, A could possibly see G if it got to that first and before the E and the C got drawn. So what we do is we connect all the points along the back of the curve. And just for this portion, that represents G and H. And along the top of the curve is E and F. The face of the curve is C to D. And of course, that line extends all the way down the structure. You know, we would have to create those. And then again, A and B and all the points beyond and before. Now what that does, so at that dashed line right there is created ahead of time, that keeps point A from seeing point E, and it can't draw that edge in there. It has to draw to C, and then it has to come back here to the next point it finds along this line. And now all of those triangles lie in their proper planes. You can see the light colored ones here are along the face of the curb. The darker color ones along the top of the curb. This darker color is along the gutter pan. All right, so that's basically the rule of thumb, that if it's an edge on the ground, you need to make sure it's also an edge in the data set before you make the surface. Okay, so the surfaces are made, the triangles are formed from point data, and it gets that data from individual points, if you have those in your drawing, as well as the vertices of any elevated line work. Even if it's all, you know, if it's a level line, that's still got some elevation, so it will read it. But 3D lines in particular, it just goes to all the vertices of that feature, and it treats that as a corner of a triangle. Okay. Now let's suppose we're doing this and we had a whole bunch of points out here on the edge of pavement, a whole bunch of points here on the top of the curb, but we only shot this corner point down here for the gutter and a point way up here for the gutter. And so the only points along that line would be down here and up here. So it would have to form triangles, and it would form a single edge between those two extreme points. So we could sometimes find a need to add additional points in between the endpoints, and they all lie along that 3D line, and they're all at a constant grade. And that's a process called densification, where we add additional vertices, and you know that's called densification, and we'll look at that in some examples. You'll see what happens, and we have some tools in the software now that it can automatically do that for us in memory, or it can do it you know, and actually add the vertices into the drawn line work and leave them in there. Or if it does it in memory, it only does it long enough to build the surface, and then it throws them away. So it keeps our drawing a little smaller. So let's do a couple of example things. Let's go back to our Carlson bit. And let's start a new drawing. And we'll just take the defaults on getting things started here. Now, if you get this startup drawing wizard, now we can start to fill this out and set things up that we don't have to do manually as we go along. So starting at the top, let's give this a new drawing name, and we're going to hit the set button over here on the right. And we're going to now navigate to wherever it is that we stored our folders, and we're gonna be working. So right now I'm in Carlson projects, but I want to be in a different location. So I can hit the browse button, and I'm going to see I'm starting in Carlson projects. And right here is the folder where I'm working today, 2022-0908 civil class. So if I double click in there and then double click in my data sets, these are all the things that I downloaded earlier. And down here for file name, I'm just going to call it surf-ex for surface example. So it'll be a new file, and I'll say, and it comes back and fills this out, changes my location, surface example, I'll say open. And I'm going to set my horizontal scale to say 30 scale. And here's a couple of key words for you. When you see the term symbol plot size and text plot size, that means if you were to plot this drawing at 1 inch equals 30 scale, you want your symbols to be 1/10 of an inch and our text to be 8/100ths of an inch. So when you see the term plot size for symbols and text, sometimes you'll see scalar size. Think of that in terms of plotted inches. And you can see it computes based on this number up here. Let's say if I make it 50, I'm just going to tab out of it. You see how it changed that to a 5 and that to a 4. And if I make it 30, you see how it changes this to 3 and 2.4. So you never have to change once you set your symbols and text sizes. They'll stay that plotted inches, but they'll change based on your drawing scale. And we're not going to worry about our coordinate system right now, and this is just an example, and we'll just say next. And the next thing it wants to know is a data path. No, it's using our drawing folder location as our data location. That's fine. We'll keep it to that. And it wants to know a coordinate file. Now this, sometimes like I do entire projects where I never use any coordinates. So for this, it doesn't matter. It's going to create one suggested to be the same name as the drawing in the same folder location. I could choose set and choose a different one, or I could choose an existing coordinate file. Let's say I'm working on a project and I've already got coordinates existing in a file, but I'm doing a new drawing. And if I want to use that, I'll change this to existing instead. But for now, let's just leave it at none or new. We'll say no import at this stage, and we'll say next. And then it comes up and it's ready to roll, ready to go. Okay. Anybody have any problem going through that part? Everybody's good with that?
No, I just, I think mine came in pre-set up already, so I don't get the draw wizard
Okay.
dialog box.
All right. So if you want to use that now, if not, you need to go to settings and choose drawing setup.
Yeah.
And set your scale and stuff here.
Yep.
Now I'm going to change this line type scale to back to 1, and that's an AutoCAD problem. Carlson used to scale it based on the scale, but it really needs to be set to 1 to use pattern lines. But anyway, so you would set yours there, and you would do a, if you're doing a new one, you might, need to do a save as and put it where you want it to go, whatever. All right, now, if you want to use that drawing wizard, here's where you set it. Go to settings, Carlson configure, general settings, and it's right up here. Use the startup wizard.
Okay.
Okay, so if you want to use that, then go ahead and do it that way.
Okay. Sounds good.
Now,
I'm sorry, Ken, not to repeat yourself, but what you did here was you opened up a new drawing.
yeah,
Okay, and you just called it surf slash exec, existing.
Uh-huh.
And we're just gonna say, because what it's doing is it's asking me for like a template, you know, I don't know, like this demo, when this thing got loaded in here, I don't have half the menus on my screen as you do.
Yeah,
Start a
so,
new,
yeah, so it's gonna ask you for a drawing template. I just took the default. It was a Carlson.dwt.
okay, okay. So I'm just gonna call this thing, yeah, I just made it without a template, Imperial without a template. We're just gonna go next. And then, okay, so to set the data path, Ken, I know you just, that data path was,
That was, well, not in here, but if I go to settings, set project and data folders,
okay, let me just do that quick. Project setup. This is the project set. The startup wizard is asking me for the data path.
okay, and is it pointing to the same place where your drawing is?
Let's see. So I go to the Carlson Civil. Oh, I got Carlson. And I got the civil training. And then I'm going to open up the civil class materials.
Yep.
And then there's the data set. I'm just going to open that up. Okay. So the data set for civil class, and then the coordinate file defaulted to surf dot existing CRD.
Yep.
I'm good. Yep.
Okay, so that should get you where you need to start. Now, we're gonna get set up in our coordinate space a little bit consistently. So I'm gonna type Z and hit enter for zoom, enter. And then the option on the bottom line, C for center, hit enter. And I'm gonna type 5,000 comma 5,000 and hit enter. And next it's going to ask for a zoom factor or the view height. Now the view height is going to be the distance on the ground from the bottom of the screen to the top of the screen. So let's just go ahead and call that 100. So now I'm about 100 feet top to bottom here and centered around 5,000, 5,000. All right, so I'm going to put in some points. So I'm going to go up to my points menu and I'm going to look at my point defaults. And I'm going to check on that I want to use descriptions and elevations. And I'm going to locate on the real Z axis. And I'm using this attribute layout ID of 2, which lines everything up on the left edges and it goes to the right of the point. And I'm going to use this symbol. If I say select symbol, I can pull this down and choose points, and then I'll choose that little plus symbol.
And we're locating on these on the real Z axis what?
That means when I put a point in and I give it an elevation, it's going to put it there in space.
In space,
Otherwise,
okay.
yeah, otherwise it will go down to 0, but it'll still carry the elevation.
Right, okay.
So I'm going to do that. I'm going to turn on use point numbers. Use automatic point numbers so they'll increase as I go along. And then a layer for the points, and you could have like P and TS in there, that's fine. I'm going to draw the point nodes. I'm not going to use annotated points because it slows it down a little bit. And so none of these others are selected. And I'll say okay. So now I've just set my defaults. So now to create the points, I'm going to draw locate points. So it now has read that symbol, read that I'm going to use descriptions, elevations on the real Z, point numbers, starting point number automatically increase. Any duplicates I'm going to erase and redraw. There's my symbol size of 1/10 of an inch. My text size scalar, see that word scalar? Remember that means my plotted inches. So 0.08, there's the layer name. And I'm going to enter and assign. That'll be the first thing I'm going to do. I'm going to enter and assign. And it wants to know, do I want to enter by grid coordinates or latitude, longitude? I'll type G for grid. And the northing, let's go ahead and just use that at 5,000. And easting,
Again, this
Yeah.
thing is defaulting to grid and latitude because what, in the setup?
when I chose draw locate points, here I'll escape and start this over. Points, draw locate points. I'm going to choose enter and assign.
So what I'm saying is enter and assign, but then the command line prompts grid or latitude.
Yep.
This is because you've set up what, a projection or something, or?
No, does yours not say that?
No, it does not.
Okay, that might, are you on the
Oh,
latest?
you know what it is? I think it's in the drawing setup. The system needs to be under grid. Let me just try that. Okay,
Yeah, right.
right. Okay, done.
Or it can even be just local. It's fine.
It could be, but then it's not going to, then it'll just ask for the coordinate, the northing and the easting.
Right.
Okay. Sorry.
No, it's all right. That's what I want you to do. So draw locate points, enter and assign. We'll go by grid, 5,000 northing, 5,000 easting. And we're going to make an elevation of 99.99. Now notice the options there, text, snap, or just enter. So if you have something already drawn in the drawing that is at a given elevation, you would choose snap and you could go over and snap to it, or you can choose T for text and it will read numbers out of the text you select and set the elevation accordingly. But we're just going to type it. So we do that. Now we'll give it a description and we're just going to call it PT. Well, we don't have to name it. We'll just call it PT for point.
Point elevation. 599.
And then you should see something like that. All right, so everybody has a point now?
Good.
Okay, now,
I don't have a point.
you don't have one, Chamizi? You don't have?
No, I probably have, it shows me that I have elevation, eastings and all of that. However, I can't see the point, even though I've set my scale already to the 5,000. You said 5,000 by 5,000, right?
Yeah,
Yeah, I don't know. Maybe there's something about, I'm not sure what should be the issue.
all right, well, let me finish this up. It's asking me for another point. I'm just going to hit enter to finish. And now when you do that, do Z, enter, E for extents, and it should blow up like that.
Yep.
You got it?
I have the point now. I can see it. I just have to zoom to extend.
Okay, and if you double click any part of that point, you
Yeah.
should see the coordinates.
Yep.
Okay. So I'm going to go back to Z, enter. Actually, S for scale. No, that's not what I want. Let's see, Z, enter, C, enter 5,000, 5,000. Height of 100. All right, so that's where I was. So now I've got this point here at 5,000, 5,000, we're 100 feet top to bottom. So let's set another point, and we'll do this one by points, draw locate points. And this time, instead of enter and assign, we're just going to say screen pick. And when we screen pick, just go somewhere else up to say the top, toward the top of the screen, pick a point. And it shows you where you picked it, give it an elevation, and we're going to call this one 108.5. And we can leave the description the same as the last time. Say, okay, so now I've got a point there. And it's still asking me down on the command line point to create. So I'm just going to click a couple more. I'm going to click one over here to the upper right. And I'm going to make that one say 106.72. We'll leave it as point, and I'll come down toward the bottom and set another one here that says the elevation. Sorry. So the elevation, I'm gonna put that back down to say 101.3. Keep the description. So I've got 4 points now in my data set.
Yeah, I can I have a question here. How do you, so you have your points, you know, they are annotated as PT. So mine is showing whatever I labeled my points as, it's just giving me the labels in the bottom, not the PT. So I would like, is it like it's just living in another layer, or I'm not quite sure like what's happening, but it doesn't show like there's another layer created. So that's what I don't understand.
Do you only see the point number in the elevation?
I see the point number, it's numbered twice. So we have the top numbered whatever, whatever I gave it, and then the bottom also where you have that PT, it's also numbered the same. So it's just numbered, it's monotonous information, I think.
Let me have you share your screen. Let me take a quick look at it.
Okay. Okay. Can you see my screen?
No, did you hit the share button if you selected it?
Yeah, I did. Yeah, I'll do it again.
Okay.
I can see your screen.
Yeah. Oh, you can see my screen? Okay.
I think so. It's Pulse Secure. Is that Ken's screen or?
Oh, okay. It's probably, it's sharing the first screen. Can you see the cat screen there?
Yes, I can.
Oh, okay. I was just sharing the wrong screen. That's why.
I don't know if Ken can, but I can see it.
I can't see it. I wonder if I've got it. Oh yeah, I can see it now.
So first of all, these are the few things that I have.
Yeah,
So
okay, I got you.
mine is bigger. You have this and this.
Yep. All right, so what you have, let me. I'll request remote control. Okay, so what you have with a Carlson point, and again, this is going to be in your training guide in that upper section back on the fundamentals part about points. But this point is composed of 3 different things. There is you see that dot in the middle?
Yes, sir.
That's the actual CAD point entity. The circle is the symbol. That's a block. This is also a block. The 99.90 and the PNY. And that block is it's a block of attributes, and those attributes are the point number, that's the one, the elevation, and the description. So when you put in a point, and I'll just double click this to, now your editor is probably on the other screen, drag it
Let me
over.
bring it to the other screen.
Okay, so that says that this point has a coordinate value of 5,000 in the north, and the easting is 99.9 instead of the elevation. That's what got you out of
Okay,
the other one, because it was asking for the easting elevation, and you put in, or easting coordinate, instead of 5,000, you put in 99.9, and that's okay for what we're doing. Don't worry about it. And then this is what gets displayed as a description. Okay, so when you enter a point, I'm just going to do another one real quick. I'll draw locate points. I can, let's see, what do I want to do? So this will be our fourth point. And I'm just going to screen pick, and I'll pick up here. And it wants to know an elevation there. Let's call that one, say, 6.23. And it wants to know a description. Now, what happened was, when you were putting your points in, you gave those descriptions the same as the point numbers, and that's okay.
Yep.
But let's just say I called it PT.
okay.
All right.
Oh, okay.
So I'm going to go back to this one now. And change its description to be PT, and I'll also change its description in the coordinate file. And I'll do the same thing for this one. And let's say that's, maybe you had a different description. So it's whatever they are. Now, your point numbers are at the top, off to the right, and then down below, centered around the point. That comes from this. From your point defaults, this attribute layout ID, and you see up here's a little preview. I used this one. That's why they're all lined up on the edges. And there are 10 different ones, 0 through 9. So I could use italics. I could use, say, one where the elevation is kicked off at an angle, like a spot elevation would be. I could use some of these others where it puts the description at the top, point number at the bottom. So you see there's all kinds of different ways you could do that.
Yep.
Point number off to the side, elevation over description. So whichever way you wanted those to be, and then of course your symbol can be anything you want. Now that's going to apply to any new ones that you create. So if we now say draw locate points, and just going to screen pick, I'll put one up here at let's say 100. So you see how that looks different.
Yeah.
Now, here's the other thing about that command, draw locate points. I could say draw locate points, and it's reading all of those things. Now, this is if I screen picked, but I could also just say draw all. And what that's going to do is it's going to read my coordinate file, and it's going to draw them into my drawing. And so it erased all those other ones I had in there and redrew them into my drawing here. Okay.
Okay. Yeah.
All right. So, so this command, draw locate points, is really powerful. It can draw, you can create points, you can draw a range of points. Let's say only you wanted to do 1 through 3. So if I just, grab everything here and delete it, And if I said draw locate points, draw a range, and I said 1-3, that's all it is.
Mm.
Or I could type ALL and it draws all of them. So that's a very common thing. You might have points in a coordinate file that aren't in your drawing yet. So you want to put them in there, you read the file and you put them in. Or sometimes you'll have points in a drawing that don't exist yet in a coordinate file and you want to put them in there. Then you would do things like this right here, where you would update the coordinate file from the drawing, or you can update a drawing from the coordinate file. So, you know, all kinds of different tools. Now, don't worry a whole lot about this because you're not going to be doing a whole lot of points. We're going to be using mostly edges. We're going to create edges to do our surface creation. But again, all it does when it creates points is it reads elevation information out of these features that it finds in the drawing that we tell it to look at. In this case, all we have are points. Okay, so, but we haven't told it to go and build a surface yet. Now it's still asking for any point numbers to draw, so I'm just going to hit enter to conclude. All right, so now I'm back to the command line. Okay, so understanding that, I'm going to actually go up here and choose erase points. And looking at my command line now, I'm going to choose to erase by number. I'm just going to say erase number 5. And because 5 exists in my drawing and in my coordinate file, it asks, do I want to delete the points also from the coordinate file? If I say yes, delete the symbol, yes. Are you sure you want to delete it from the coordinate file? Yes. So it's now gone. And I can take a peek also here on my points menu, list points. I'll list all my points. And now
Okay.
that's on your other screen and you can see those.
Yeah.
Those things, and just, you can close that window off now and that finishes out that.
Okay.
Okay, yeah, so yeah, just close it there.
Okay.
All right. So that's
Yeah.
one other way you can verify what's in the drawing and what's not, compared to what's in the coordinate file. All right, so for now, I'm going to go ahead and I'll stop yours and I'll put mine back on.
So Ken, every point that you create would, it means it would have to live in a coordinate file, right? When you create any point.
No, when we typed in and when we clicked on the screen, that is putting them in that new coordinate file that we made.
Yeah.
So every Carlson point that we choose is going to create a point in our coordinate file. So if we do something like enter and assign or screen pick, every time we do that, it adds a point into whatever coordinate file is active. See, there's my first one, and you can see these others. Okay.
Okay. So, but the first part that we have to, in order to do this, we have to, in order for the points that we create to live in that coordinate file, the first thing to do is to assign a coordinate file to the project, right?
Yeah.
And then when we create it, sends it to that coordinate file.
Right. So if you didn't start with the wizard, that remember when we went through the wizard and it asked us for a coordinate file and it used the same name?
Okay.
If you didn't have that, or if you opened up a drawing that you didn't have a coordinate file with, and they don't have to be the same name, then you would either set the coordinate file and you would choose either new or existing.
Okay.
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 Choose
Yeah.
it. Or if it doesn't exist yet and you go to create it, it's going to ask you at that point to tell it what coordinate file to use.
Okay.
Okay. So now we've got some points that we're going to use to help create some information. Now,
Okay,
if we wanted to draw a boundary, let's just connect these points 1, 2, 3, 4, and back to 1. And that's going to need to be a 3D polyline from where those points are located. Okay, and so there's a couple of ways we can do this. We could just use the plain old AutoCAD 3D poly command, 3D poly. And it says, okay, give it a start of the polyline. Well, if I want to, I can snap to that location either by snapping to the center of that symbol, or if on my snap settings, I would turn on node snap and let it snap to the point. Okay. In which case it would, snap to the point, go along like this. And then I would close back. And so that's now a 3D polyline connecting all those points.
Yeah.
Now we're looking at it.
excuse me, Ken. So
Yes.
so when you snapped each point, it just lets you're able just to snap them like right away. But for mine, what is happening is when I snap, it requires that I enter. And I snap again, enter, snap again. How do you avoid that from happening? Is there thinking there's something in the setup that I need to do? Like it wants to confirm the point elevation each time.
Okay, did you type 3D poly?
Yes. Yep.
So if I type 3D poly, now again, this is just the CAD command. So the start is going to be, if I snap to there, and now it doesn't say next.
No, like how yours is snapping right now, you're able just to flow like right through. Mine
I
doesn't flow
see.
as such. It makes me enter.
Yours went something like this.
I think what he's saying, Ken, and it happened to me too at first, if I go up to the draw menu and pick 3D polyline through the menu, mine does like he's saying, but when I just type the command, I think I'm getting the AutoCAD command.
That's right. That's what I was showing you, the difference between the two commands.
Yeah.
What you get, if you go to draw and choose 3D polyline, you've got this set on to prompt for the elevation. And if I
That's
do
what
that,
happened to me at least.
see, and now it's going to ask me for what elevation to use. I can say 99.99. I can go there and it wants me to confirm 108.5. Enter. It wants me to confirm 106.72. Now notice I could type this at say 105 and come back to that. We'll keep that one where it was and we'll type through the place. Now, so this corner, if I sit in that vertex and look down here at my status bar, I see that is indeed at elevation 105, but it's not at that same point. That's what that is for. When you draw a 3D polyline, if you say prompt for the elevation or slope, if you don't have that checked on, it will read the elevation and go to continue. But the command, if you type 3D poly, that's a completely different command. It's essentially going to create the same thing, but that's the AutoCAD or IntelliCAD command, whereas draw 3D polyline from the menu is a Carlson version. I wanted to show you the differences between those two commands.
Yeah, I did that. That's still happening. I tried both of them and it's still asking me to confirm elevation for some reason. So I'm thinking one overrides, the Carlson version overrides that AutoCAD command.
Maybe. Let me take a look and see. Go ahead and share your screen again.
Yeah. To share. So when I go here, draw 3D, approve.
Okay, now show me again.
When I draw 3D, right? And I click on, you see, it's asking me to have to
Yep.
enter
Right,
each time.
yep,
So, and then I go to 3DP, 3D. Okay, say,
3D.
okay, it's 3D, not 3DP.
No, it's 3D POLY. 3DP is the Carlson version, so 3D POLY.
Okay, 3D poly, 3D poly. Okay, I see. Yeah, okay. I see. I was typing 3DP, which was just creating like a line with a gradient. Sorry.
No, that's quite all right. Now, what's going on, and I'm gonna show you here, you've got an endpoint snap set in your settings here.
Yeah.
Which on the other screen, but anyway. You missed the center point. You missed that node and you grabbed the corner. So that's one thing to really be careful of. You can grab the corners of these symbols. Okay, so you didn't actually get that point. You got slightly off of it. You would need to have this point go from there to there.
Okay.
Okay, so you need to be careful of that when you're trying to screen pick things. But now here's the nice thing about the Carlson version of that command is when you're using Carlson points, and that is, let me see, where are your, yeah, there we go. Any tools are, oh, it's over here. The thing about the Carlson command is, and this is why I recommend always using these Carlson commands. You notice one of the options says pick a point or point numbers. So if I just say 1-4, 1 to 4.
Yeah.
Wow. 1 to 2 to 3 to 4. What on earth? Why did it come in curved? Take a look at something here. Now, I'm going to turn that on for you. I'm going to uncheck the prompting. I'm going to uncheck this autocorrect for 90-degree corners, and I'm going to uncheck smooth polyline. That's why it put those curves in there.
Okay.
Okay, so now I say 1-4.
Nice.
So, but now since yours are sort of out of order, what you could do instead of 1-4 makes them cross. We'll just take any, we're going to say 1 to 3, 2 to 4 to close. Okay, or I could have typed 1 again, whatever. So now I've got that figure drawn and it goes exactly to where the point is in the middle. And if I select that and hover, I see that that is at 101.2, so that's correct. Okay. So that's the advantage on a lot of these things, to draw 2D polyline, 3D polyline, circles, rectangles, anything with a Carlson command. It's going to ask you to either pick a point on the screen or it will ask you for point numbers. And again, if you go back to the front part of the manual, there's in those point exercises, it shows you a lot of the usefulness of those point number ranges. Okay, so but we're not going to spend a whole lot of time with those. All right, so I'm going to come back to my share. And we're back to here. Now, remember on mine, I put this in at a different elevation just to illustrate a point here. So let's go to the view menu and choose 3D view and drawing viewer. And wants us to select the entities. We're just going to draw a window around everything. And it's going to show up in this 3D viewer. Now yours might be, small like this. I'm going to make that full screen just so you can see it better. And I'm going to make sure that my ignore zero elevation is on. It doesn't matter now because nothing is at zero, but you can see right now where I've missed this point right up here. Now it should in pure plan view, it should be right at the center because that's where it is when I'm here. See, it's right there at the center. But what's going on when I use that command is I'm in a perspective. Pull this off a little bit here. Let's see, let's draw. See, I'm actually in a perspective view. So even in plan view, I still see the things that are closer to me, which is the top parts, is, and the back of that little cube that was this box isn't exactly underneath it because it's showing me in perspective. Okay. So if I pull this around, you can see now how that elevation at 105 was not the same as 106.25 or whatever that one was. Okay. So I'm going to exit that and I'm going to fix this elevation. And I can do it any number of ways. I can actually, if I hold the shift key and use my mouse, if I can get my mouse wheel to work. I hold the shift key and press and hold the wheel on the mouse. And it's not seem to work. There it is. It finally did. You hold the shift key and push up. Oh man, this is frustrating. I need a new mouse. All right, let me set it another way. All right, so anyway, I can roll this thing up and look at it in 3D. Now notice down here on my icon, it tells me I'm not in plan view anymore. I've got this 3D rotated view. So I could do something like this. I could just grip at it, just grab that grip and snap it right up into that location. I could have done that. Oh. I could have looked at that at 106.72 and I could have set it by stepping through these. That was originally 105. Okay, so I put it back there. So I can select this and click on the vertex number and step through till I get to where I want to be. And then I could have typed that in right there, or I can choose that little pick button and have it pick that location, 106.72, but I missed corner. There it is. I missed the actual point. So any of those methods are fine. Again, we're just making sure they line up. But I'm going to go back to plan view. I'm just going to type the word plan, hit enter one more time. Get rid of this stray that I had. All right, so again, if I draw a 3D polyline and use point numbers, it's going to always go to those exact point number in elevations. But if when you draw 3D polyline, if you don't have this box up, down at the bottom of the screen, you'll see O for options, and it'll bring this up. So if you have prompting turned on, it's going to ask you to verify. If you don't, then it will just read the point. Okay. So now we've drawn a couple of those edges, and if we were to build a surface out of this, it's not going to be, it's going to need to create a triangle across here somewhere, either between these two or between these two. And what controls whether it draws those or not is part of the algorithm for when it builds a surface. It depends on which point it goes to first, and then it looks all around itself and tries to connect to other points. And then it goes to the next point and does the same thing, goes to the next point, does the same thing. And if it sees a line already created as part of the surface, it won't cross it. So to show you that effect, let's go to the surface menu and choose triangulate and contour. Now, let's uncheck these. I'm going to draw triangulation faces. I'm on the triangulate tab. I've got draw triangulation faces turned on. I'm going to uncheck this use inclusion exclusion areas. And my shrink wrap perimeter reduction, I'm going to leave to none. We'll talk about that a little later. And erase previous contours. I'll say the current surface. I'll ignore any zero elevations. I'm going to uncheck everything else on this tab. On the contour tab, I'm going to uncheck that. I don't want to draw any contours yet. So labels is off. My selection tab, make sure everything's unchecked on these first two boxes, because I'm not going to limit my selection. I'm going to read everything I can read. And then I'm going to say OK. And it asks me to select the points and break lines to triangulate. Remember, I said it reads points and it reads line work and it reads all of the vertices in the line work. So I'm going to just select everything and hit enter. And there now are the triangles that formed. So this would be, 99 goes up to 106.72, whatever that midway point is there, and then it's 108 and 101. All right, now those are triangular faces. And if I look at those in my 3D view again, you don't need to worry about loading this up. You can see what that looks like. Let me give that some vertical exaggeration. You see how it's sort of folded there in the middle, like that. See it?
Yep.
All right, now, if, on the other hand, if I'm going to erase these, and instead of that one, let's say I had this drawn in here as a 3D polyline from 2 to 4. And now, if I triangulate and contour again, keeping the same default, and I also select that line, notice it's now drawn that instead of that. And so when I look at that in my viewer, I can see it's a ridge instead of a valley. Notice that difference? And so that's why it's important to have the 3D lines in that represent edges in the drawing. Now, we'll keep that as a little ridge instead of a valley. I'll put that 3D line back. Now let's go back to surface, and you can either draw that in or not, don't worry about that. But let's go back to triangulate and contour, and this time, let's go to the contour tab and say draw contours. And let's make sure it says contour by interval. And the contour interval we want to set is just 1. We're going to use 1 foot contours. Just take the defaults for the layers. And so the check on to draw the index contours, and that's going to be 1 and 5. No smoothing. Go to the label tab. There's no need to, well, let's go ahead and label them if you want. And let's uncheck everything here except we're going to label the index contours only. I'm going to uncheck that. And I want to hide the drawing underneath the labels. Align the text with the contour, draw it on the real z-axis so it draws it at its elevation. That means draws the text at that elevation. I'll hide the drawing under the labels. Now what that's going to do, I could come up here and say break the contour at the label, but what that's going to do is that would actually break that contour line. I don't really want to break it. I want to keep it continuous, but I will hide the drawing under the labels. And I'm going to come down here at the bottom and I'm going to say draw 1 label per contour. Now, when this hides the labels or hides the drawing under the labels, it uses a wipeout under the label. And so everything under that little square wipeout gets hidden as if it were broken. But it doesn't break it, it keeps it intact. And there's a reason I want to do this way for what's going to come up next. So if I say okay, and I'm just going to select everything. Now there's my contours. Now I've got some different text styles that I maybe could change, but let's say you have drawn your contour maps and the labels might be in an inconvenient place. Well, up on our surface menu, under contour labels, you can, if you don't break it, you can move the label along the contour. And when you do that, you just pick on the label and notice I'm not snapping to anything. I'm just repositioning something to make it a little better placed. Okay, follow how that works. And it moves the label and the wipeout right along the way. Now, to show you what that is, if I turn my wipeout frames on, see, there they are. So it's actually a piece of text and a wipeout together as a group. And if you look at this, the elevation between 108.5, whatever that is, and 101, so that's, you know, about halfway in between those, and be like 104, 105. Here's my 104, here's my 105. So that follows right along that line, and it works correctly. Okay. Now let's clear that out a bit. I'm going to go to my edit menu and choose erase. And I'm going to choose erase by layer. And I'm going to say all, and then I'm going to say select the layers from the screen. I'm going to pick one piece of text, one of the contours. That's for the intermediates. Same thing for the index. And that will take everything on those layers and erase it. Now the surface, if I had saved the surface file, we did not, but if I had, you would still have the surface. You're not getting rid of the surface. You're just getting rid of those drawing contours. Now, let's erase by layer one more time. And I'll select this triangular face. Get rid of that. Okay, now I've got this as a 3D polyline. And I'm going to draw 3D polyline, and I'm going to draw around my figures again, around the outside edges. Okay, just to show you what happens. So when I draw these triangles, you see how large those triangles are going to form, and they're just these 3 points. These 3 points. Now, they are, let's figure out how far apart they are. If I look at my distance command, if I go from here to here, that's like 100 feet, just under 100 feet. So if we were to do this instead, let's take this line, that 3D polyline, and let's densify it. I'm going to go to edit, polyline utilities. I'm going to densify those polyline vertices. Okay, and I'm going to select my polyline, and I'll give it an interval of 10 feet. Okay, so now when I select that, notice it has all of these vertices added into my polyline. Okay, but you can see if I go back to my viewer here, you know, they're all still all in a line. Now, I didn't change the grade. All I did was add extra points. So now, if I go back to surface, triangulate and contour, and say okay, and select my data, look at all the triangles. Actually, let me try that one more time. And I'll turn off draw contours. So now instead of each of those big 3-point triangles, because this line in between had all of those extra vertices, see, every point gets considered to be part of a triangle. And it formed all of these extra triangles as part of my surface. Now, if I look at that in my viewer, you know, it still looks exactly like it did before. And even if I draw my, if I were looking at it as a surface file, I could see the contours. I can't do that with this, but you see, so that doesn't change the surface in that particular instance. But sometimes you need to add extra points if you're, you know, if things are not, you know, if you got really long triangle edges that really should have a little more definition, it will help smooth things out a little bit. So if I turn on and off this little icon here, you can see the triangle edges. Okay, so they formed because of those extra points. Now, I'll go back to my erase, and if I want to get rid of those extra points now, I'm going to go back to edit polyline utilities, and I'm going to reduce polyline vertices, take the default cutoff, select that, and now when I look at it, it's back to the way it used to be with only the endpoints showing up. Okay, because the others were close enough to being in the same line that it didn't need them. Jimisa, you had a question, yes.
Oh, it's fine.
Okay.
Yeah.
All right,
Ken, I got a quick question if I may.
Yep.
I see under triangulate and contour. Under contour, I see here this subdivisional surfaces scan drawing or scan the CBO file. Way on the bottom. Yeah, this scan DWG, scan CRD.
yeah.
What exactly is that doing? I don't recall ever seeing that.
Let me show you what that does. Let's see if it's gonna explain it a little better than I can. Subdivisional surfaces, it just to indicate the degree of triangle subdivisions. What that does, it causes each triangle in the surface to be subdivided into that many triangles. X plus 1 squared triangles, where X is how many subdivision generations, how many times does it go through trying to do it. Mathematically generated subtriangle vertices are raised or lowered to provide smoother contours. Okay, so it will adjust their elevations as it subdivides those triangles to try to smooth out the contours. And more generations increase the smoothness, blah, blah, blah. So it won't produce any crossing contours, but it could result in contours that aren't really part of the surface, because you might have graded slopes that show a different transition. Okay, now.
All right, I'll take that. Okay,
So-
thank you.
Yeah, so what that means is if you want to do that to smooth your triangles, let's say you did, you see the little preview that's showing you?
Yeah.
So it draws the contours and then it smooths them out. Now, here's the problem that I have with that. Let's say we do it, then I'm going to do it all the way across here. I'll draw the contours. I won't label them anymore. And I'll just say, okay. So now they look nice and smooth, don't they?
Right.
Okay. But that's not what my surface looks like. So I should be able to look at this thing as a surface. And let's turn these off for a minute. Okay, so that surface should gently warp and have some sort of curved edges to it, but it's not really doing that. It's still, my surface file is still very hard edge single triangles along those edges. And what you really need to do, and this is what I try to teach in my classes. When you triangulate and contour, reduce the temptation to use smoothing. See, because if you got a real tight situation, if you see up in that upper right corner up in here, you run the risk of, when you smooth that contour, you could have some contour lines that cross the other contour lines. And all you're changing are the drawn contours when you do the, when you build the surface. So that was if I had taken this, I had done this, p-edit, I select this, and I said, okay. So you see what happened. Remember where the original was. Sorry, I keep hitting the F1 key. And then smooth that one. Smooth that one. So you see what it's doing is it's picking up that original contour and it's putting a smooth on it. It looks nice and smooth, but it moved the contour up from down in here, right in here where it used to cross, and it moved it up to here. But my surface is not that elevation there. It's slightly higher than that contour. If I look at my drawing inspector and I turn on my elevation, if I look at this elevation, see it's 106, 106, 106. But watch when I come down this line. It's 106.3, it's 106.265. And it doesn't get to 106 until I get down here where that used to be. Right in there. That's where 106 really is on the surface, not up here, even though I smoothed the contour. So it's not reality. It's not, I haven't really made a smoother surface. It just looks pretty.
Right.
All right. So
So in regards to smoothing, then, is there a limit of smoothing that you would recommend? I know everybody likes smooth contour lines.
I would recommend, instead of smoothing, I always leave this off. So
Always leave that off.
instead of smoothing, I would put in additional things, additional points. See, the reason that was really sharp edged was because this went from these giant triangles. So they went jump, 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 jump. So if I want smooth triangles, I need to put more data into my drawing to make it smoother. I can do it a number of ways. We saw when we made all those other little triangles in here because we used that densified polyline. That's
Right,
one way
right.
of doing it, all right? But now, if I go back to triangulate and contour, notice on the triangulate tab, I've got this button down here that says densified break lines. Well, I've got these lines drawn. Now they're just point to point to point right now. But if I say densify the break lines, and let's make those every 5 feet instead of every 10 feet, and you'll see what happens. I'll say, okay, we'll select all of this. And hit enter. So now you see, I've got as if that line went every 5 foot and dropped a point in. So it formed all of these triangles, even out here on the edges. But if I go here and clear that, I'm just going to delete these.
And that would reflect then a truer representation of the surface and introduce a little bit of smoothing.
Yeah, so, but if I look at these polylines now, you see they're still only at the point, it didn't put the points in here.
Right.
Like it did when I went to Polyline Utilities Densify, wherever it is, right here. That added the points into the drawing. I didn't need them because my triangulate and contour command will do it in memory. Now, that being said, you notice I still, even with that densified on, I select everything and I get all those triangles, but notice the contours are still angular. Okay, because they're all planar. There's nothing in here that tells it to transition from here to over to here. So let me show you how we fix that. I'm going to draw 2D polygon. And let me make those just kind of. All right, so I'm going to draw a 2D polyline just across like this. And line layer. There we go. And I put 7. All right, so I've got a 2D polyline. I'm going to array that, or let's just make a few copies. Let's just copy. No, it's offset. Say 5 feet. Let's offset multiple offsets, 5 feet. Let's say 15 repetitions. Okay, that's good enough. I don't need these two. Now, what I'm going to do is trim those off so that they only go to the edges. So I'm going to select that, right click it and trim. And why isn't it?
How did you do that multiple offset routine? What the
Edit,
edit?
offset, multiple offsets.
Edit, offset?
Okay. So now I've got just a bunch of 2D polylines, which you can see.
Hmm,
One second.
gotta give it a thumbs up.
See how they're down here at 0. So what I want to do is give those polylines elevation. So they're going to start at whatever elevation is over here, and it's going to go to this line and put it at point there, and then it's going to go over to this line. So how do you do that? How do you set those to those elevations? And that's really a big part of what we do in grading control. So we're going to go to the 3D data menu, and we're going to say, turn that 2D data into a 2D polyline into a 3D polyline. And the method we're going to use is by screen entities. So we'll say, choose that. And I can have it extend across any gaps. I don't have any because I'm trimmed exactly at the edge. Ignore any 0 elevations. Now, not the elevations of the lines themselves, but the things that we tell it to look at. Extrapolate end elevation, so if that went on out, it would continue that slope to the end, or if it's not checked on, it would make that 0 from whatever that elevation is on out to 0. I'm no need to keep existing. I'm not going to change the layer. I'm just going to convert these. So I'll say okay. Now select the polylines to convert. Those I'm converting. Now select any surface 3D faces, lines, and polylines. Well, this one and this one. Enter. Now, when you look at that in 3D, you can see that they do in fact go up and over and across. All right. Now, that being said, if I were to triangulate and contour without the densification, and I select this, you see the triangles formed exactly like they did before, but the contours are still sharp, okay? So let me clear these and select. But if I were to densify these, watch what happens to the triangles now. And I'm going to go back to triangulate and contour. And I'm going to put the densify break lines back on. And so now I've got a whole bunch of different contours. Now I see my or a whole bunch of different triangles. You see now that they're as if they had individual little nodes that formed. This is really a bad example. Sorry. Let me, show you a better example over here. All right, what's this? I'm gonna draw a rectangle. And I'm just gonna draw from here up to here. Okay. And let's give this some elevation. So I'm going to use my polyline elevation editor. I'm going to select this. So 1, 5. So 1, all right, so I want 2 and 3. I'm going to set those to be an elevation of 98.85, let's say. Oh, sorry, I put the wrong. Put it
So
in the
you
wrong
just
box.
move everything up? Is that what we just did here?
I went to the 3D data command and chose the elevation editor. And I selected points 2 and 3 and I assigned their elevation.
I
Okay,
got you. Okay.
now, suppose I wanted to set this edge. Let's suppose this is a building over here with a finished floor of, say, 99, and it drops down here. This is a parking lot, maybe. Okay, so it's level all the way across this edge of the parking lot. But let's say I wanted to come down this edge at a 3% slope, and I wanted this edge to come down at a 1% slope. So if I go from 3 to 4, 3 coming into 4, I'm going to make that slope minus, let's make it 3.5%. Let's make it. It goes down to 96. All right, so it's not going to be a very proper parking lot. It's 7.5% slope. So it goes from 98.85 down to 95. So that'll be enough to see some contours. Okay. And I want to go from 1 to 2. Instead of 7.5. Let's say I want to make that a 5% slope. Let me see, I did that the other way around. I'm going to do that. I need to. I want to change the direction of the polygon. So 95, 95, 95. All right, so 2 to 1, 1 to 2. 2 and 3, I'm going to uncheck these. There we go. 2, 3, and 4. And now two to 1. All right, I want to reverse. Direction. Ah, they moved it on me. Okay. This down here is, so now I'm going to reverse the direction of it so I can go from 4 into 5 instead of, so 2 goes to 3 at 7.5%. 4 goes into 5 at, instead of, let's make it 3.5%. And then 1 and 5 are the same elevations, that's correct. All right, so now what we have starting at point 1, which is the same as 5, it goes to point 2, it drops at a negative 2.95%, goes to point 3, it climbs up at 7.5%, 3 to 4 is flat across, and then 4 goes back down to here at only 3.5%. So that's what I want out of this. So now when I look at that in my 3D viewer, you see it's flat across the back, which is this line over here. But it drops down to this corner faster than it drops to this corner. Okay, so it's sort of a little twisted shape. Now, if you don't do anything with that data and you triangulate and contour, oh, sorry, let's triangulate and contour without the densification on. See what that's done is it's put in those sharp angled contour lines. Let me change this to be half-foot contours. All right, so that would be, if I were to look at that, and if I were to go out there and say, build that with my 3D machine control, greater, see, it's going to make a nice sharp crease down that valley. All right, but that's not really what I intended. What I intended was for this thing to start at that level elevation and drop down to that 7.5% this way, 3% that way. And it should be a nice smooth transition. Okay, so I'm going to draw, let's put these this way. And let's
Sorry, that this part which creates the array, where did you go again? How did you do it?
how did I do what now?
The one that creates the arrays on this line, this multiple. Okay,
Right
okay,
there.
multiple offset. Okay, thank you.
Yep. And I will trim off those edges now. Instead of having, say, that ditch line, now if I pre-drew that line down corner to corner, it would hold that crease, but I don't want it to be a crease. I want it to be a, see right now it's, you see the contours, it makes a crease. So I don't want it to be a crease. I want it to be smooth. So the way I do that is I'm going to need to, so let me do this Ah. Hold on, so I'm gonna try this again. So if I were to do this way, I still, you see, I've got one triangle this way, one triangle this way, okay? What I need to do to make that smooth is I need to make those triangles, I need to, you know, in these lines, oh, wait a minute. Oh, no, I forgot to do. Was 2D to 3D polylines by scheme entities. So I'm going to convert these by that. Okay, so now when I look at this, that's what it should look like. You see how that's smoothly warps instead of having that crease down the middle? So now if I triangulate and contour, and again, I'm not going to turn on the densify yet. So now my contours no longer are sharp down that corner to corner, but look what happens to them. They look sort of stair-steppy, don't they? And the reason for that is because these triangles go all the way across edge to edge, and there's no other data in between there for it to look at. It's just going along that long edge. So what I need to do is make sure that I get I read all of these different points. Now I can do that by, you know, identifying polylines, or if I just do it in memory by turning this on here, and I select my data. Notice the triangles now, there's all kinds of individual little triangles, and it went every 5 feet along all of those yellow lines. Let me put these in the back. So you see all of those yellow lines, it put a point every 5 feet and every 5 feet along the edges. And now when I look at that data that I generated, now my surface is nice and smooth without that crease in it. And the contour lines, look how smooth they are. See the white lines, those are my contours.
Yeah, yeah.
So that's how you do that. Now, if you don't do it that way, and if you say triangulate and contour, and we'll undensify contour line. Let's see, let's make sure we get back to the sharp ones. There's the sharp ones again, right?
Yep.
Okay, so if, however, you decide, well, I'm going to turn smoothing on, right? Well, when you do that, you get smooth contours, but look how they're kind of goofy looking, and yet I'm still, when I look at this in 3D, I still have, all right, so I've got those nice smooth contours, but notice how they're not, you see those yellow lines, how they go up here above?
Right.
What contour lines are. So all I did with those contour lines was really just smooth them and move them up a little bit. Okay. But the surface is still just that triangle and that triangle. And it looks like, well, can't see quite so readily. There it is. So my surface is still, see how it looks there? it's like it's got a solid crease in it. Let me see if I can't. There we go. You see a little better. See, so what happens, you know, if I turn on contour smoothing, yeah, I've got a nice smooth looking contour map. But if I need to take that surface and put it on a machine and tell it to go out there and grade my parking lot, I'm going to get a nice crease down the middle of my parking lot. And I don't want that. I want the surface. Oh, quick second. My brother called. So I want the actual surface that I want. I'm going to turn my smoothing back off. I'll densify. I've got additional data. And now I've got enough information that when I look at that as a, you know, a surface that is level out here and it drops down 7%, 7.5% this way and only 3.5% that way. The contours that result from that surface are nice and smooth because I've got additional triangles in them. Okay. So that's what that densification does. And what you sometimes have to do is you've got a lot of really long distances without data in between. Okay. And sometimes it doesn't matter. Let's say if let's say I built that parking lot and I really wanted it to go with a crease from this corner to that corner to make a drainage channel, then all you would do in that case is simply, oops, change my settings here. I've got, there's a endpoint. I would simply draw in a 3D polyline from there to there, and then I don't need any of this stuff because this crease is going to force everything down to it and force everything back up out of it. So, but if I look at this, you see, that's not exactly the same thing. See how it sits underneath all that?
Yep.
Okay, but if what you want is that crease, then you would not use the yellow lines, you would just use the white lines. So that's getting really nuanced in terms of, you know, what we're doing. And now what I needed to do in this case was, if I want to make those smooth contours, I would take that line out. 3D to 2D. And produce. And then 2D to 3D, that's green entities. Then triangulate and contour, densifies on. And now, if I look at those, I'm just going to get rid of the triangles. Let me see, so now my contours, you see, are really smooth. And it works nicely edge to edge because I put all of those lines in there and then told it to densify everything.
And this then is just more an accurate mathematical model.
Yeah, if that's what I want. Like I said,
That's what we
sometimes,
want.
yeah, sometimes you really want that to be an edge, that crease from corner to corner, okay? And if you do, then you need to draw that in as a break line.
Right.
Much like, let's say there's a curb running through there. Well, I want to make sure that that is a curb, and if it curb, starts at this point and goes down to this point with no change in slope, there's no high point or low point, then I just go from that point to that point, and then when it densifies, it puts all those little points down there to make those extra triangles to make it smooth. Now, it's a trade-off. You can make too many, or you
It's got to
can.
really increase the size of the drawing, though, no?
Well, that's only if you draw all the triangles. Now, normally when you triangulate and contour, you wouldn't draw the triangular faces. You might just do, well, we don't do that. And turn this back on. So if I triangulate and contour, so I wouldn't draw the triangular faces, but and of course my contour lines would be, set that about to 11s and 5s. And then I could freeze. That data. Now there's my contour lines. Now they're nice and smooth without
No, it looks good.
me, telling it to turn contour smoothing on.
Right.
Whereas if I did it without those yellow lines, you see it could be, well, let's try that one more time. Without the yellow lines and without densification. Now you see, of course, this time it drew the triangle edge up here instead of this way. So they're sharp and they go right along. See how it bends at that point?
Yes, sir.
Whereas it also would bend at that point. Now, if I triangulate and contour and include that information and densify, that'll smooth out those stair-steppy looking things and makes really nice smooth contours. Okay. So to sum all that mess up is resist the urge. Even if you were hired to, create me a contour map so I can, I'm an engineering company. I hire you as a surveyor and I say, create me a contour map. Resist the urge to simply turn on contour smoothing because it might look nice.
Right.
But it could be.
It just,
Yeah, so it could be like if you did it and you didn't densify, you didn't have the extra data. Make sure that's the original looks like that. If I did it and I said, well, okay, I'm gonna make sure I turn on my smoothing. Say, okay, well, that's nice and smooth. Yeah, it is, but that's not what the surface really is.
right.
Modeled. Okay, so you got to be aware of what it is you're trying to do and how fine-tuned do you need to make this. Okay.
So if you were to turn around now, I mean, that's a 3D polyline from 1 to 2 to 3 to 4, and then back to 1.
Yep.
And you identified those elevations of that polyline. They're different from the point elevations. you generated that 3D polyline by setting that up and going down 7.5%, and now it's going to be flat, and it's going to be,
Well, I did that on this piece over here that I erased.
okay.
So this is back to the original now. These match those points.
So if you exploded that 1 to 2 to 3 to 4 line and erased like 1 to 2 and from like 3 to 4, the contouring would still be the same.
To a point.
To a
Yeah,
point.
in this case, it would because of the shape of this. But
Right.
if I had a shape that looked like this. And if I did nothing about it, it would put triangles in this spot. over
Sure.
So that's why I need to put a boundary around it. There's all kinds of considerations that you got to do.
Right.
You know, because
thank
this point and all the points along, they can look over here and see these points. So that's why those triangles will form. And you'll get contours in here that are probably invalid because you don't really know what's going on right there. If this is all the data you have, right? So that's
Right.
what that's about. And we'll see some of that here a little bit later. But let's for now, let's take our
Right.
afternoon break. And I'll give you your full 15. So we'll come back at 3:30 and wrap up a little bit more and learn how to use the 3D viewer and see where we go from there. Okay. So I will stop our share and I will. Because it's good, very possible I would have gone right past it. So anyway, so what we're going to do next is we're going to open the files. And let's navigate to where we are working, wherever you stored your data. So I'm going to go down to civil class, data sets. And I'm going to look for a file called sample from T3 global. And I'm going to choose open. And you should see something like that. Everybody got that okay?
Yeah, just getting to that file.
Okay, okay.
Open. Save in the training.
Now this file, as you can see, it's got some elevation information in it. And we'll take a look at all the different things we're going to need to be aware of.
Church. Mining case.
All right, everybody got the file open? Will, I saw your thumbs up.
Not yet. I don't have it yet.
Okay,
Project. Okay, civil
And this
class.
is
I'm good.
okay,
and this is within that civil class materials data
Correct.
set.
yep. It's called sample from T3 global.
Sample from 3T global.
Oh,
Okay.
oh, sample. Here we go.
Specify
I was looking for
this one for
some of the shape files are missing. Ignore.
Yeah, just ignore those things.
so it says
Okay.
it says to
All right,
specify. I'm sorry. It says to specify a replacement for each SAH.
Yeah, just cancel that. That has to do with some text and line styles and stuff. You don't need to worry about it.
Okay,
Okay.
I got it open.
All right, so we've got a drawing like we received from somebody else. Okay, in fact, this is a real job. It's got data in it that was from a photogrammetry firm. So they created this information to generate a contour map of this site. Now, you see there's a lot of busy stuff going on. You see all these white lines, these kind of things. Those are those break lines that these people put in. Like if I look at these curb structures, for instance, in 3D. Oops. See, they've got the face of the curb and the top of the curb, and they're at their right elevations. Now, those are wedge curbs. So they're, they just got the bottom edge and then the top edge, and it goes back at a slant, it's that kind of stuff. All right, so we'll select. Oops, no, that's not what I wanted to do. Yeah, see there, you can see. So when they did this in photogrammetry, they went through and looked at the aerial imagery and they created these as break lines. If you're doing this as a surveyor out in the field, you might survey this point, survey that point, get the back and the top of curbs, and you would then connect those points together with 3D lines so that you have the break line information that you need. Now, here's an example. If you look, you see these lines right here. These two pink lines. Those are lines that are on the ground in 2D. Now, they don't match up right here in the corner. They probably should. But something caused them to, maybe it's an error. Maybe that really should go like that to line up a little better. But those purple lines, they have 0 elevation. You see right over here in my properties. They're drawn down at 0 elevation because those are just the drawn edges. And you would use those to do your final mapping, and you would turn off these 3D edges. You would just freeze these particular layers. So I'm going to go to my view menu and choose freeze layer by pick, and I'm going to pick one of those white lines. So now everything else that's in here, that would be the delivered map. And I see a bunch of points. You see these pink looking points that are spread throughout here. You can see the pink dots.
Right.
So those are a bunch of points. You may not even, maybe you would freeze that layer too.
Those are points obtained in the field or from the
No,
photogrammetry?
from photogrammetry, yeah. They would, if you did all that in the field, those would represent points that you just shot out on the ground. So
Right,
anyway,
right.
They used all those points and all those white break lines to create the surface, and that's what drew their contours. Okay, and so they would draw that as a contour map. Now, if I look at this in 3D, the only thing that's in that with elevation are the contour lines and a few selected spot elevations. Okay, but how they came up with those contours was by modeling all of those points that I turned off and all of those white lines as break lines. And then they put these edges in here just down at 0 elevation, because if I wanted that to be, well, let's take, for instance, this polyline here, maybe I wanted it to be, oh, I don't have the right line type. Let me see. Yeah, as soon as it finishes loading. here. All right, now, so, maybe I wanted that instead of being whatever that's defined as, maybe it's supposed to look like a center line. All right, so if that were a 3D line, where I went by screen entities, I selected this and told it to use everything it crosses, then that's now a 3D polyline and it's set correctly, but notice it no longer looks like a center line. And that's because AutoCAD and also IntelliCAD, neither one can show a patterned line if it is at 3D elevations, at differing elevations. It has to be planar for that line type to show up. Okay, so that's why they put those down at 2D, because you might, want to show those as a pattern line. Or you might have a radius that's a true arc. Now, these don't happen to be true arcs. You see they're little segments. But sometimes a drawn true arc, like a curb return in a parking lot, it can be circular, but when you make it 3D, it can't show that as a 3D circle. It has to put it in as little individual line segments. So that's another reason to keep them as 2D as well. Copies of these, that all of those white lines were right over top of all these. So you could use the 2D lines to measure radius values and things like that, show line styles, and you would freeze all those other things, but you would use those 3D lines to create the surface. Now, one of the things, and Will in particular, the type of work that you guys do, sometimes all you're given is a drawn contour map. And if you try to build a surface from the contours, well, you could do that. Let's go to the surface menu and choose triangulate and contour. When we go to the triangulate tab, I'm going to uncheck these top boxes, but I will turn on write the triangulation file because I'm going to save the surface file because I can look at it later. And I'll hit the select button and I'm going to type in EX-bad-1. This will be existing ground, but it's going to be bad. It's going to be 1. And I'm going to uncheck my densify. I will ignore 0 elevations. Otherwise, it's going to pull that surface down to those 0 elements. So I'm going to leave that on. I'll leave these values in here as 2000 to 2000 for maximum edges. Now I'm going to go to the contour tab and I'm going to uncheck draw contours because they're already drawn, but I want to show you what's going to happen. And I'll look at the selection tab, make sure that they're unchecked. So it's going to use everything we select. Okay. We'll say, okay. It's going to now ask us to select the points in the break lines we want to use to contour with. So let's just select everything and hit enter. It comes back and it says writing a triangulation file, blah, 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 EX-bad-1. So it created it, didn't give us any errors. However, let's take a look at that surface. So let's go to the view menu, 3D view, surface file viewer. And this time we're going to pick that EX-bad-1 and open it up. And well, okay, we got a surface, but we got some problems with it. And I can show you where those are. I go right in here. I've got this long looking, like a ramp, and all these other rampy looking things in here. And if I look down the edges of my road, I got all these stair steppy looking things. All right, and the reason that is, and notice I've also got all these triangles out in here that don't mean anything, okay? But we didn't limit it. We just said, take the contours, which were these. And start to build a triangulation. So out in here, these points out here, we're able to look over here and see these points. That's why all those triangles formed. But, and we need to have a line around that. We'll get to that later, okay? Down this road edge, we need a line that connects all of those points all the way down to keep what happened when we did the surface is it's looking at this contour line and it sees a point here and it's looking over here, sees that point, that part's okay. But then when it sees here, it looks over and sees this point. So it makes that flat across there. And that doesn't really happen. It really goes from here down to here. So this should go from here down to the midline and then back up. So that's, you know, that's an example of a break line that needs to be in there. That's the edge of the road. Same thing with the, with all of these curves. For instance, you can see the contour lines, you know, they come up, they hit the curve, they walk up and they come back down. But if we don't have these edges in there as break lines, you're going to start to flatten this out across, you know, from here to the other line across in there. Okay, so there's a lot of information in here. Like we just built the surface with only looking at this contour line data. And so if we were to draw those triangles, it would, you would see them draw across here. Let me see if I can show you that. Let me then go to. So now you see the contours that you see in here. See there, I made those flat spots in there and it jumped across. It went from here on this contour line. It even, you know, went straight across and jumped up to itself and then jumped down to that corner. So those are things that we need to fix with break lines in there. See, that point in there shouldn't be there. You know, we should have a break line from this point here down to that point there so that this point can't look across it and see that point. It forces it down to that contour line. Okay, so, and we've got the same similar type thing right in here because it went from these upper contour lines up here and looked all the way down to that contour line. That made that little ramp. Same thing with these in here. That's really a wall in there. If we go back and look at that, see, that's a retaining wall. It's a little loading dock in there. They just broke off the contours. So we would need, if all they gave us were these contours, even though we didn't get an error, we can look at our surface and see we've got a problem because we saw those areas out here where it jumped all the way across here and didn't. And it, you know, it doesn't know any better. It just has to form that triangle there because we didn't tell it otherwise. So we go back to the view menu and let's turn on this thaw on all layers. Now, when you see these, here's that break line, and let's look at how these contours. This is the area in there where that big loading ramp looking thing was. Let's just take a look at what they look like here. So you can see that's what it should do, and that should form a wall. Now, They did it with theirs because they used that. And that's why the contours come up to the edge and stop, go down to the bottom and stop. Okay. So we need to be aware of things like that and things that can cause errors. If we look over here in our road, for instance, you can see the same thing where they've got this white line here runs down the noses of all those contours and makes a break line. So now points on this part of the contour can't look across it and connect up and make flat triangles. Okay, so those are some of the things we need to do. Here's an edge of a little piece of sidewalk. So there's a couple of ways to deal with this. I'm going to go back to view and freeze layer by pick, and I'm going to turn off my break lines again. And let's assume that all we had were these contour lines that have elevations. Now we can do a couple of things. We've got the drawn edge, so we could go up to 2D to 3D by screen entities, and everywhere it hits a contour line, it's going to put a point down at that elevation. It's going to go to the next one and put that point down. But there also might be an elevation somewhere in between here that's not, you know, it's not exactly linear when it changes. Like you would get if you had that 3D line that came out of photogrammetry or from the field, by survey. So we would, if all we had were the contours, we would have to somehow elevate all of this information. We would take this wall and we would say, read the elevations of everything you cross and, you know, set the elevations accordingly. So that works somewhat, but you're missing stuff in between the contours that might be happening. We don't have any idea or any way of getting that if they don't give it to us. Same thing down here on these road edges. We could draw these lines or elevate them and have them read the information as they go across. But sometimes we don't have it. Like right in here's one, they missed right in here. They really should have. I'm sure they have it in their 3D data. They've got one turned on in there. Okay. But sometimes that's all you have. And you have to balance, you know, how much time do you spend trying to condition the data versus how much time do you have to get the job done and how important is it? So there's a couple of tricks that you can use. Look back at surface, triangulate, and contour, and this time, let's turn on this one particular switch right here called minimize flat triangles. And you see it says adjustments for source data of contours. So if all you have are the contours, you can say minimize flat triangles, and what it's going to do, we're going to go ahead and do that. We'll say, okay, just use the same file, overwrite it. And we'll select it. We also have the points now. So now let's go back and look at this information. Whoops. Sorry, let me try that one more time. So if we look at this information now, and we add the surface to it. Turn that off and back on to get the color right. So now we have less of a problem up there because we had these points down here. And notice in here, we no longer have quite so radical a bunch of flat triangles because we told it to minimize the flat triangles. It still has some right in here. It still has plenty over here on this edge. Let's see if I can Let me see that a little better. There you go. So we still have these problems over here that we didn't fix, but we managed to fix these over here. So there's a couple of little techniques that you can use to help. They're not 100%, but they help. So when you do that triangulate and contour, understand what these are going to do for us, just like we did with densify break lines. I'll put that back up to 10 feet. Now, when we ultimately build a surface from that, we're going to use those break lines and points and not use the contours that they gave us. I'm gonna say yes, and then I'm going to just stop that. All right. So being aware of what data you have to start with and deciding whether you need to add additional data is going to be important. Here's another common thing that happens. Sometimes you'll have these curb lines like this, where they put in the face of the curb and the back of the curb, but maybe instead of that being a structure that looks like, seconds. I've got to turn back on. And so instead of, maybe instead of being a structure that looks like that wedge curb, maybe all they gave you were the face of the curb and the back of the curb, and they'd say, well, it's understood that the top of the curb is right above that face of the curb, but they don't give it to you as a 3D line. So you have to come in there and create that. And you would do that with a command. I'll show you real quick. We're not going to worry about it right now to follow it, but if I do a 3D offset by interval, and I'm going to choose the horizontal amount of, say, half a tenth, just a little bit off, a vertical amount of 0.5 feet, so 6 inches tall. I'll select this guy, and I'm going to go to that side. So now what I've created is a structure that looks like that. See, it's now got that 3-dimensional edge to it. And now, if you remember, I put in the horizontal offset of 0.05. I didn't say 0. That's because when you're building triangulation files, you can't have a vertical face. And the algorithms fail when it goes to compute volumes when you do those with vertical triangles. It will do it, but it will complain about it. So if I were to do that same command and set 0 for my horizontal amount, and I select this,
The horizontal cannot be 0.
yeah, the horizontal you can't have a vertical face, even though see, let me get all of it. Let me get this one too. I mean, I can create it. I can create that as a 3D line.
Right.
You see that one right there, the one that's outermost.
And that's
That's
directly
vertically-
above the other one.
That's vertically above the face of curb. But when I go to build this as a surface, and I'll just,
Then it'll be an issue.
you see, it gives me all these vertical edges.
Oh, I see.
So everywhere along there, it's going to give me a vertical edge. And the reason that's a problem is when it makes a triangle, right in here, it tries to make the triangle in there. Let's see if I can. show it here. See, it tries to make this triangle right in here vertical. And if I look at the triangles themselves, it's these triangles out here that are vertical. And then when it tries to compute volumes compared to another surface, it does that by going to the centroid of each triangle, dropping down or going up to the surface below or above it, and creates a small cylinder to compute the volume in that cylinder, and then adds up all the volumes of all the cylinders to get the total volume. So what happens when you get a vertical face, a vertical triangle, it goes to that, and that's, remember, it's sticking straight up in the air. Now it goes to the center of that, and it goes down and it hits another triangle, and it comes back up and tries to hit another triangle. So if I'm down there on another surface and I'm going up and I'm trying to hit that triangle, it can't find the center of, it can't find where it intersects that triangle, because it intersects it all along a vertical line. It needs to intersect it at a single point to be able to construct that prism in there. So that's why we can't do those vertical faces. And we have to have that little bit of an offset backwards to keep that from happening. Okay, so something like that would work just fine, but it's set back just a wee bit. I did 0.05. It could be 0.00001. It just, as long as it's not 0.
Just as long as it's not plumb vertical, okay.
Yeah, correct. Now, Tamizi, this is going to be a potential issue with you in terms of some of your mining faces and such, because I'm going to draw something over here in plan view, or in cross-section view. Let's say I've got, I come along and
Okay.
let me change that. Oops. Okay. There we go. So if I've got, across the top of my surface that I'm mining, and as long as I come down here to the bottom, so what, crap, did the wrong thing again. Hold on. Let me just turn that into. All right, so I'm going to offset this. No, I'm not. I'm going to copy this. So what this might, really look like. That might be our mind face or something. Maybe it's not quite so severe like that. All right, so if I'm looking at this in cross section, and if I build this as a surface, well, this is okay because it's not, the triangles it builds here are going to be leaned back a little bit.
Yeah.
But reality, especially in a mining situation, you might have a situation like that. Okay, where you've got the top of this face is further out than the base of it. Okay, so this is going to be some issues, because if you think about that in terms of contour lines, if I were to, draw the contours that form, say, at this elevation, it's going to go around this way and wrap around and then it's gonna go higher, and it's gonna wrap around this way. Well, this one is going to then, in plan view, it's gonna stick out further than the one underneath it. So it's gonna have a contour line that's gonna look something like this. You know, and then as it wraps around the face and comes back, and then I'm gonna have another one, say, higher up. And it's gonna do something like this.
That's correct. I've seen that before.
Okay, and that's not valid. I mean, it is valid in that it represents what's going on, but it messes up the math when you're trying to use that to compute volumetric analysis. So that's why you can't have any vertical faces, or not only vertical faces, but what are called supra vertical or beyond vertical.
Can you break it at intersection then? That point, if you want to create a surface, can you do it? Can you break those points where they intersect?
Well, you could, but that makes a discontinuity in the surface, and you're trying to represent the actual ground. Now, there's a couple of other little tricks in here where you can pick a reference plane that's not level. And so that lets you set a reference plane that's tilted so it accommodates that forward sloping face, but then that screws up everything else outside of that area.
Yep.
So that doesn't really help us in that regard. Now, what does work okay generally on the mining side is that instead of using triangles, it's going to use it's going to do these 3D grids. Now, the difference was, remember when we did triangles, let me see if I can. So there's our triangles. You see how they form, and that was just that last set of data I used. So instead of putting points where it finds point data, when you do gridding, it looks at that information and it drops a point at a regular interval all along all of your data. So what happens in a case like that, when you have that versus, say, this, you're going to wind up getting a point here, and it'll go through all the different surfaces and just at every regular interval, and you get out to an area here, and then it might go over here and skip past this and go down to catch the next one. So it would really have the same effect as if you were drawing from, as if it went from here to here and then down to here and out, that being matched up here. But so it would quite often overlook that overhang. So you still don't get the modeling, but you don't get the errors when it goes to do the computing. So it's just the nature of how it builds surfaces through triangulation. Now, there's another even more complex modeling technique, and it's not something that Carlson does other than with its point cloud information, but it's what's called surface meshing, in which case it will allow you to do those. And if you think about if you're inside a tunnel, well, how do you model inside a tunnel? Because you got points directly overhead that are the same XY location as the points you're standing on, but there's two different elevations. So that doesn't make a contiguous surface in terms of a triangulation, but as a mesh, it's able to do that. And that just gets a little beyond the scope of what Carlson does in general engineering terms. But as you know, those situations can exist in reality. You just can't draw a contour map of them. Okay, you can cut cross sections of them, but you can't draw a valid contour map because contours are not allowed to cross, and you're not allowed to have those vertical faces. Okay, they'll be near vertical. That's why when we saw this line, this wall over here, when they put that wall in, you see how it's leaned back at the top.
Yeah.
Okay. Now that wall actually is leaned back at the top in reality out there on the ground. Because it's one of those, stacked block walls and they leaned it back. So that part's there. Now, we got about 5 minutes left. I want to show you some things on that 3D viewer to help you visualize some of this information. If you look on the view menu, 3D view, we've got these two different choices. One's a drawing viewer, one's a surface file viewer. And if you choose the drawing viewer, it's going to prompt you down on the command line to select the entities. And that's where you select things. You hit enter and it shows you the information of those things that you selected. Okay. On the other hand, I'm going to freeze this off a minute and go back and rebuild. That bad surface again. Okay, so now I've got the surface built. So on the other hand, if I look at this 3D view surface file viewer, it's asking me for a file. So I'll choose that file and open it up. And it loads it up. And you can see this little switch over here on the side that looks like a fishnet.
Yeah.
I'm turning it on and off to say everything it did. It read the surface file and it created all these as 3D faces, which are solid objects. It's exactly the same as if I had drawn those faces in my drawing and selected them and looked at them in my viewer. So it's really the same viewer. But you got a couple of other little extras that you can look at on the settings menu. You can say display the contours. And you can change the colors of those. I'll get this to come back up. Set colors. No. Well, I've got something going on. Oh, there it is. So let's set my contour colors to this sort of darker orange looking thing. And let's maybe change my surface. All right, so we're in the surface viewer and we can look at the contours. Now, those are not the contours that they drew. These are the contours that would result if we had drawn our contours as part of our process. See, there's that bad one.
Yeah.
Okay, over in here's our little flats. And again, we can turn the triangles on and off. We can say, draw the triangle edges. And if we do that, you'll see the triangle edges are showing even when it's colored in. All right, so there's a couple of little differences. There's also a difference in right down here at the bottom is that we have some editing, some surface editing things that we can do, like add a break line. And I'll come over here. I have to use this tool add a break line, and I can come in here. And let's say I know that, well, I need to have a break line from here down to here. Now watch what happens. Bad place to look at it. Let's try it right in here. Ah. Let's go from here to here. All right, let's go to here. Maybe if I go from here to here, why is it saying that? Let's see. Oh, there we go. So I added a break line from that corner to that corner. Maybe I wanted to do one from this corner to this corner. So it heals up those bad areas. Now, if I'm back over here on these flats, let's go from, say, here down to here.
Are those
Yep.
edits changing your 10 file, or are they just changing, are they just viewing for viewing purposes?
Well, for right now, it's just viewing, but if I were to do this, say from, let me see if I can, I want to get, I really want to go from there to there. Let me do it. So from over there, let's see if I can fix it this way. Yeah, there we go. So now I fixed that little flat area in there. Okay. And now the question is, am I really fixing this, or is it just in the viewer? Well, right now it's just in the viewer. But if I go to exit, it says, you want to change, save your changes. And you say yes, and you could give it a new name or whatever. So that would let you do it that way. But that's a lot more tedious than if you go out here and put the data in place. So you don't have to remember all those edits that you made. You've got data that you can go back and rebuild the surface again and model all of that stuff correctly. Okay. So now, back to that viewer, again, the only difference between the two is what it asks you for to start with. You can, in either case, I'm doing the drawing viewer now. I load up my data, and then I can go to the model tab and choose and turn that off and look at these different things I can add. I can add a surface. I'll right click and choose add a surface, and I'll add this surface to it. And there it is. It pops in and superimposes itself over what I am showing in the data set. Okay, so these contours are the drawn contours. But likewise, I can look at the surface file. And let me turn off these edges and these contours. And I can go to the model tab. And now instead of these things, I can choose add entities. And I can select all of these drawn entities. And now you see the drawn spots and contour lines that were superimposed over top of the surface file. Okay, so it's really one and the same, with the exception of, and again, you can turn on and off, you know, different different layers to control, you know, what you're looking at. Just like on the other way around, if you load something up take a look at it. You can still do that same thing over here under layers. But if you add a surface to it, the problem with the color, you have to reset that. You can go back to the model tab and you can open this up and you can say hide the surface or show the surface. Or if you click over here, double click surface to toggle the visibility, and just double click it. Okay, so it's really the same surface and everything's controlled by these settings and this view control. Now, again, in the book, a lot of those things are explained out here pretty heavily. So if we were to look at, say, the surface, we can look at color by elevation. And that shows us there's some different color schemes based on the lows and highs of our elevation. It's also a very excellent way that if we had some things shown, let's put a polyline over here. And let's set its elevation to, say, 10. And if we looked at that, and we see the elevation range now is low numbers down here all the way up to the 1400s. But so that tells us we've got a stray piece of data that shouldn't be in there, which we can also see by this bounding box. You see how it includes that. So that's a good way of looking at what we have. And the color by elevation was surface only, or if I say all, it will color everything there. Now let's go back and take this out and look at it. So there now, that's a good indication of good data. We've got lows in the blues, highs in the reds, mid elevations in the greens. We look at the numbers and that looks like about what we expect at the site. We look at our bounding box, which is over here. You can put labels on it if you wanted, or turn it off. But that gives you a good way to sort of look at your data to make sure there's not any major problems with it. Okay. Usually, a lot of the folks at Carlson, they look at everything with color turned on. I myself don't generally like to do that. I like to see what color they are in the drawing, or in terms of a surface, if I have a surface loaded. You know, I can set that surface to a particular color. And if I'm looking at more than one surface at a time to look at differences in the way I modeled it, then I would maybe have one surface green, one surface red, and I can see where one sticks up through another one. Or if I'm looking at existing versus design, I can see those two surfaces in different colors. Okay, so those are just a couple of things that we have in there. We're going to, tomorrow when we go into this, I'm going to show you how you can really quickly figure out, you know, what you want to look at, what you're looking at, where everything is. Let's say if I wanted to look into that pond over there, you know, I would lay this thing back and spin it around and then zoom into it. So I'll show you all those controls and what they do when we have a little more time in the morning, okay? So for now, I'm going to have to scoot and get onto my rehearsal. And I will see everybody back at 9 o'clock Eastern time tomorrow morning. Any questions before we go on stuff today?
I'm good.
Okey doke.
Yep, I'll see y'all tomorrow.
Yep, so make sure that you, when you get a chance, you don't have to do it tonight, but just after class is done next week, whenever in the coming days, go through in some depth in this guide on some of those concepts, and they'll help to cement that. Because normally we spend 2 days in a fundamentals class, and that's where we spend a lot of time on these tools over here that we've been using. And the draw tools, we just take a lot more time to go through that. We just don't have enough time and still get through the grading and road design stuff that we got to do tomorrow. So,
That's
All right.
good.
so with
Sounds
that,
good.
I will stop the recording.